and then he'll be addressing those as soon as he has a second. On the bottom of the screen there, you'll see your resource center again. That's where we have all of the additional content for today. All right, what that looks like, we are all set to begin again. At this point, I'm going to pass it back over to your instructor. Sandra, you're all set. You can take it away.
Thank you, Pat. Hello, everybody. Welcome back to day three. So day three, as I promised yesterday, is going to start with our topic of resizing logical volumes. So let me bring up my system. What are the main topics today? We have some little ones. We are going to do the boot procedure. We are going to hack the root password. We are definitely going to do SE Linux, some auto mount, and some other little topics as well. SE Linux will be the big topic of the day. In case you were wondering when is it going to happen, well, that will be today. Let's start talking about logical volumes. So what I would like to show you is how to resize these things. When we use df-h is showing available disk space. Here we have this beautiful dev mapper VG data LV data. I'm calling it my LV data logical volume. And you can see 1.9 gigabytes total. 8 gigabytes is not too bad. But if I go to use ddf is df is slash lv data slash big file, bs is 1m, and I don't type anything else, and it's only a matter of time, and oh, that was fast, before we have run out of disk space. Here we go, df-h again, and lv data is 100% used. So that's our usage. Now, if you are talking about resizing logical volumes, what you need to resize is the logical volume as well as the file system. The file system must support your resize operation. If you are using XFS, XFS can be grown. You can't shrink SFS. If you are using ext4, you can make ext4 bigger as well as smaller. So I need mount pipe grab LV data. And what do we see? Oh, that's good. We have ext4. Well, there is no shrinking involved here because this volume occupies 100% of all the available disk space. So we need to make it bigger. If you want to make it bigger, then you need to always one level up. So I am going to use VGS, and VGS is giving me the overview of volume groups. And what do we see? We see that we have VG data, and in the last column we see a V3 of 0. No available disk space in the volume group. What does that mean? Well, that means that at this moment I can't grow my ext4 file system because logical volumes get disk space from the volume group. And in order to grow the logical volume, we need the disk space to be available. There's no disk space available. So what are we going to do about it? Well, in order to grow the logical volume, we first need to grow the volume group. Now, in case you have a hard time memorizing all of these different commands, I would warmly advise to type VG and press the tab key twice. That is going to show you all commands that start with VG. And then it's just a matter of reading which of these beautiful commands do you think is going to extend the volume group size. Well, that shouldn't be very difficult. That should be VG extend, right? But before we are going to do it, can you please think about what is involved? How are you going to extend your volume group? Well, what was a volume group again? The volume group is a collection of all storage that is available in the physical volumes. So if you want to make your volume group bigger, you need to add a physical volume to it. That is something that we should show if we use VG extend minus minus help. And there you go, VG extend is giving me a VG as well as a PV. Let's use fdisk minus L. And oops, that's a lot of information I don't want, but also the information that I do want. This is the information I was looking for. We have NVMe 0 and 2P8. That's an LVM partition. Notice that it's not yet. Oh, it is. It is already. I wasn't aware of that. I'm so sorry. It is already a PV. I didn't want it to be a PV, but hey, it is a PV and it's not used by anything. But even if the partition is not marked as a physical volume yet, VG extend is automatically going to mark it as a physical volume if that is necessary. So I am going to use VG extend, VG data, dev, and VME 0 and 2P8. And that is going to add this new physical volume to the volume group. And now I'm using VGS again. And what do we see? We see 1067 megabytes available in the volume group. So now I can grow my logical volume. And how are we going to grow the logical volume? Well, that would be LV something. Again, I like to use LV, press the tab key twice, which is showing all commands that start with LV. And hopefully it's not a surprise that there's an LV extend command that can be used here. Apart from LV extend, there is also LV resize that work. Now I'm going to use LV extend. And in order to use LV extend, I need a couple of options. Let's see if we can find it using minus minus help, because minus minus help sometimes is good. So LV extend is giving me minus uppercase L size plus size, or minus lowercase followed by the number of extends, and plus number followed by a percent. That's really a beautiful option, and that's the option that I'm going to use. An option that I would almost consider a mandatory option is minus R for resize FS. If you use a resize FS, then in the operation of resizing your logical volume, you are also going to resize the file system on top of it. Because if you resize your logical volume and you don't resize the file system, well, your new storage doesn't become available. That's not really cool. So in all resize operations, I would say always use minus R to resize the file system as well. And what would that make for the command? Well, I would say LV resize minus R for file system minus lowercase l, and let me do plus 50% free. The amount of disk space you want to assign completely depends on what you want to accomplish. I just want to show you how it works. So I'm doing plus 50% free. Then we need the LV name, dev VG data slash LV data, and that should do it. Is that so? Yeah, that is so. As you can see, a lot of output. So in the output, we can see that first it changes the size of the logical volume to 2.5 gigabytes. Then it's telling us that it is found in ext4 file system. That's a minus R option. The minus R option is checking what file system do you have, and it's automatically triggering the resize to FS. That's nice about the minus R option. The minus R option makes it you don't have to think about the file system that is used. It's automatically doing a resize to FS in this case, and it will do an XFS resize if it finds XFS. That also answers what you can do if you forget to use this minus R option. Very simple. You resize the logical volume. You forgot to resize the file system on top of it. Well, just use the file system appropriate utility, like resize to FS in this case. And you can do that separately once the resize operation is complete. That shouldn't be a problem. Good. So we can verify at this point using df-h. df-h is showing that we have devmapper VG data, LV data, and this devmapper VG data, LV data, as you can see, has now 382 megabytes of available disk space, and that is exactly what we wanted. So I would say mission accomplished. A resize operation complete. Now there's a few questions that you could ask about this. One question would be what is going going on if one of the physical volumes in this logical volume breaks, well, I can just say then you have a problem. So at this moment, we have this LV data, and LV data is on top of the volume group. And this volume group is using two physical volumes. And if one of these physical volume breaks, yeah, I can only say you have a problem in that case. And your entire logical volume is becoming inaccessible. But hey, this is RHCSA, and in the RHCSA exam, you don't have to be smart about it. You just need to know how to resize your logical volumes, and this is how it works. Let me type history. There you go. Here is the history, and this is what I wanted to tell you. Right, I'm getting back just a little bit. This was the LVM resize, and we have a couple of other options. You can probably see that I'm skipping a couple of slides that are in the slide deck. These slides are here for your information still. They are not really relevant for the exam. As I told you before, I am going to make sure that everything that does matter for the exam is covered here in class. There is a topic that I would like to tell you about, and that is process management. So let's briefly do process management. Scheduling wise, I'm going to do SE Linux in the second hour. So I might be filling up our time before we go in the second hour with some smaller topics. Process management definitely is a smaller topic, and hopefully a topic that you are already largely aware of. So I'm going to cover some of the highlights of process management, and then we move on to the next topic. Now, process management, what do we need in order to manage processes? You need a PID. Hopefully you know that PSAUX is showing PIDs that are available. OTL wants to know about GPT partitions. TL, okay, you got it. I'm going to show you GPT partitions. I can do that. That's not very long, but in order to show that, I need to power off. I'm powering off, and that is for the simple reason that I need to assign a new storage device. I'm doing that right now, and I'm aware that probably you don't see what is going on, and that shouldn't be a problem. And let me do something fun. I have NVMe all around on this disk. I'm going to add a SCSI disk. And we are going to see what's happening after adding the SCSI disk. So it boots, and oh boy, do you see that? If I add a SCSI disk, I am getting in the bootloader menu. That is because if you have SCSI and NVMe, VMware wants to boot from SCSI and not from NVMe. That's a little fun fact. Well, is it fun? I'm not even sure about it. It's a little fact that I need you to be aware of. So I am getting back, and oh boy, I'm messing up my virtual machine environment because I need to bring it down. Where is it? Shut down. Shut down. And oh, you don't see my virtual machine anymore. I'm fixing that right now. A virtual machine coming up right here. Not much going on, but yeah, you probably want to know what exactly is happening. Now I'm back in my VMware controls. You can see the VMware controls, and I am going to remove my SCSI disk or make it an NVMe device. So that is what should have happened right now. Fun thing is, if I change my hardware, I notice that my virtual machine is leaving the building. So I need to share it again. I can do that. Oh, funny. VMware just crashed. That doesn't happen too often. That's why you don't see the virtual machine at this moment. I'm fixing that right now. Just checking in the virtual machine that I see nothing but NVMe devices. That's confirmed. I see nothing but NVMe devices. And you probably want to follow along as well. I'm fixing that right now, and you should see what is happening. Waiting for it, and it should be booting. And there we go. We have the login prompt. At the moment that you see the login prompt, that means that your primary boot was successful. Here we go. Now, why did I do all of this? There was a question about GPT devices, and I want to show you how to manage GPT devices. Still skipping the system not registered. Go away, system not registered. And getting back to my terminal. And there we go, and LSBLK. And LSBLK is now showing NVMe 0 and 3. Now, if you need to manage GPT partitions, you can use fdisk on dev NVMe 0 and 3. And then you can see that fdisk by default creates a new DOS disk label. That's not good. A DOS disk label, yes, that refers to Microsoft DOS back to the 1980s. DOS disk label comes with an MBR partition. And I don't want an MBR partition. I want to create a new label, and this new label should be a GPT partition table. So before doing anything else, and this is something that you can only do before you are doing anything else, because once you have created partitions, it's too late. But now we have just created a new GPT disk label. Just as a fun fact, some people think that you can convert MBR to GPT, and it's true. If you meet very specific conditions, this can be done, but the conditions are so very specific that it is extremely likely that if you are trying to convert MBR partitions to GPT, that you will lose access to all of your data. So I would say just consider that MBR partitions cannot be converted to GPT. That's a safer solution. Now I'm using P, and what is P showing me? It's showing me this label type GPT. So that is what you can use in case you are wondering, oh, is this MBR or is this GPT? I'm using N, and there we go, partition number 1 to 128. The fact that it's proposing to create a partition and number it between 1 and 128 is sufficient proof. This is GPT. For the rest of it, it is really very familiar stuff. So first sector, last sector, plus 1G, and there we go, it is created. Another fun fact, if I'm using P again, then we can see the partition type. And yeah, the partition type nowadays works with these links. So if I use T to change the partition type, we have the aliases. If you don't use aliases, but regular partition types, then you can see that every partition type has its own UUID. That's really something you don't want to use. You want to use these aliases. I'm not going to change partition type, so I am just going to Q out of here. Does that work? And yeah, that works. I don't need to change it. I'm just going to W and write it. So now I have a GPT partition. TL is asking, how do I know when to use MBR or GPT? Well, TL, you know that because somebody's telling you. If on the exam they are asking you to create a partition, you create whatever you want, because apparently that's not specific. My advice on the exam, before you start and do anything with your partitions, do an fdisk on your primary disk like NVMe 0 and 1. Use P and check what it is. If you see disk label type DOS, then you're talking about MBR partitions. If it's a completely new disk, then it's up to you. In real life, I would say if you are in cloud instances typically use MBR. GPT is not very common in cloud instances. If you want to address big disks, big being bigger than 2 terabytes, then GPT is your only option. And that is how it works. Good. Process management. I'm showing you DDIF is dev 0, OF is dev null. Uh, I have been doing so many slides. I want to do some stuff without slides if you don't mind. I'm going to run these processes a couple of times, 1, 2, 3, 4 DD processes. Next, I'm going to use top. And what do we see in top? We see that I have 4 DD processes. The DD processes are the busiest processes, and each of them is getting 50%. I know 48 point something, I'm calling it 50% because we don't really care about point something. Hey folks, based on the data that you see here in the percent CPU column, can you guess how many CPU cores we've got? Of course you can. If we use 4 DD processes, every DD process is trying to completely saturate one CPU. So I have 4 DD processes getting 50% each, then we must have a 2 CPU system. We can easily verify that from top. If in top you type 1, look at the third line, then you can see that I get a line CPU 0 and CPU 1. Now, first thing I want to show you is how you can re-nice processes. Re-nicing processes is about changing the priority of your processes. Very easy. I'm using R for re-nice. I like to do it from within top because top is showing me results immediately. So I'm using R for re-nice, and it's asking me which process I want to re-nice. By default, it wants to work on the busiest process. Works for me. So default PID, I'm pressing enter, and then to value. The values are -20 to +19, where a negative value is increasing priority and a positive value is decreasing priority. If you want to increase process priority, you need to be a root. That's something that ordinary users can't do. So I'm going to set to -10, and we are going to see what's happening. And do you see what is happening? We now have this process 6849 running with a higher process, and the scheduler has decided that this process can completely saturate one CPU core. Now, do I like this? Well, honestly, no, really not. So I am going to use a K to kill a process. The command is kill, but if you use the kill command, really you send a signal to your process. And this signal is a special instruction. So I am going to send a signal to process 6849. And I'm pressing enter to show you to send it the signal 15. Two signals are commonly used. Signal 15 is the decent signal like, hey process, can you please stop? Signal 9 is the harsh way of cutting off your process. Signal 15 in most cases is enough. It will go away. Another process has gone away. You can do this command line as well, but if you do it command line, then you need to find out the appropriate syntax. But hey, let's remember 6848. So renice minus help. How does it work? Well, renice works with a priority and a PID. So renice 10. What did I just say? I said it, but I don't remember. 6848. So 6848, we are going to renice the process. And now I've seen enough, so I'm using kill all DD to remove all of the DD processes. JD is asking if the pastebin shows a different date label from yesterday. No, it does not. Pastebin is just a dump of my complete command history. I don't think it saves the date anywhere. But JD, it's simple. Yesterday I typed about 300 commands the day before. I did not create a pastebin. So that's only one relevant pastebin for what we have been doing so far. Okay. This all is probably stuff that you already knew. Now I want to talk about stuff that not everybody knows, and that is the tune D process. What is this about? This is about system tuning. System tuning, performance optimization, is something that can be very complex because there is so many parameters that you can tune on a Linux system. And if you tweak one parameter, it might negatively impact other parameters. So tuning systems is really a science all by itself. And I can tell you, I've made good consultancy money out of system tuning. Now, since RHEL 7, RHEL 7 dot something, Red Hat has introduced Tune D. So the first thing we need is a daemon, systemctl status tune D. And we can see it's enabled and enabled. It also shows as inactive, and that's something that you can ignore. Uh, I consider that a bug. It should be telling us that tune D is actually running. And I'm going to prove that that is the case. I'm going to use tune D ADM minus minus help. This is one of these commands where I don't care about remembering command line options. Now, tune the ADM works with different commands, and these are the commands, the positional arguments. And that is what you are going to work with. So I am going to use tune the ADM list for all the available tuning profiles. Ignore this error message. This error message is not is a part of the bug that I was telling you about. It's not really critical. Now, what is going on? Well, in the past, you had Linux system parameters, and these parameters were just standard parameters. There was no tuning going on at all. And that is why it was very easy to tell to somebody who owns a Linux server, hey, do you know your Linux server is poorly tweaked? Of course it is poorly tweaked if it was never tweaked according to the appropriate workload. Nowadays, now that we have Tunedy, you can select one of these profiles, and based on the profile, you automatically get some optimized settings for this typical workload. So it has even detected the best profile for my system. That's something that you can find out using Tunedy ADM recommend, and that is telling us that it recommends a virtual guest. Now, how does it do that? It is doing that by having a look at your hardware, at some drivers that are running, and based on what was found on your system, it is recommending the best profile, performance profile for your system. And you can also change that if you want by using tune the ADM profile balanced. Now, what is balanced? Well, balanced, here we can see that's a general non-specialized 2D profile. It's a little bit of everything. It's the classical solution where you don't really optimize for anything specific. You are just trying to get the best generic workload. Now, if I use tune the ADM list again, what do we see? We see that the current active profile now is set to balanced. Now, was that easy? I hope it was, and I hope you are going to remember this because you might see it on the exam. Little bit of background, what is behind these profiles? Well, we have user lib tunedy. In user lib tunedy, look at that. We have subdirectories for all these different profiles. So if I'm picking out any profile like desktop, then we can see that there's a tunedy.conf. So if I'm going to cat on this user lib tunedy desktop tunedy.conf, here we can see the current parameters. Now these parameters are about sysctl tunables. That's not something I'm going to explain today, but if you want to know what this is all about, come back next week. Next week I'm teaching some sweet advanced Linux classes, including my new security class and also Linux performance. I don't want to go there because this is really not something that you will see on the R8CSA exam. Now, fun thing is that we also have etc tunedy. And hey, in case you are wondering, what is the difference between userlib tuned and etc tuned? Well, the answer to that question is basically the same as the answer to the question, what is the difference between the systemd unit files in userlib systemd and etc systemd? Well, what you find in userlib is system defaults coming from packages and candidate for updates if ever you are going to update your system. What you find in etc is your own customization. Let me show you something funny. I'm going to use mkdir etc tune the sander, and I'm going to use cp from user lib tune the desktop tuned.conf. I'm just copying over a random configuration file to etc tuned sander. Then systemctl restart tuned. I just want to make sure that that the tuned daemon is aware. Tuned adm profiles is sorry, tuned adm list is what I should use. Is showing me what? Well, look at that. We have Sander optimized for the desktop use case. Of course, the message optimized for the desktop use case comes from the tuned from userlib to the desktop that I copied over there, but feel free to put any tunable that you want to have in this tuned directory. And that is kind of cool because that means that you can easily tweak performance according to your needs. You can create your own profiles and just make sure that the tunely.conf relating to that profile is copied over. And that's a task that you could do perfectly using Ansible or anything like that. So that was Tunely. This was process management. As I was telling you, today is about little topics. I'm scrolling forward. MB is asking, so etc tuning is where the conf file should live. MB, not exactly. Your customization, if you want to create anything custom, you should put it in etc tuning, name of your profile /tuning.conf. Standard conf files are in userlib tuning. So if you don't change anything and you are just working with the standard profiles, userlib tuning is what you are going to use. I hope this answer makes sense, MB. If not, feel free to follow up. Okay, scrolling forward. Let's talk a bit about the boot procedure. What is in this topic about boot procedure? Well, first we need to talk about grub2 runtime parameters. I'm going to demonstrate, but I first want to tell you about systemd targets before we are going there. Because really, systemd targets is one of the most important things that you want to do on these grub parameters. So, what is grub? Grub is the bootloader. And from the bootloader menu, you can pass custom parameters to tell your system whatever you want to do. Well, you know, apart from grub, there's something funny I can do. So I'm going to do a quick demo anyway. I'm using a reboot. And before I'm using a reboot, I'm going to tell you what is going to happen. My system may or may not show a grub bootloader message. So I need to be ready to press the escape key. The escape key should be pressed immediately after you see your firmware boot screen. My firmware boot screen, that will be a VMware screen that will show up very first. Directly after that, when it disappears, press escape if you do not see the grub boot menu. I also have a dirty trick. If you have a hard time accessing the grub boot menu, the dirty trick is while your system is booting, reset it, and your system will know that the last time it didn't boot successfully, and it will automatically show the grub boot menu on the next boot. I mean, this is one of these things that can cause a lot of stress on the exam. You are rebooting, you want to have access to the grub boot menu, you don't see it. What are you going to do? Well, while it is still booting, before you see the login prompt, reset your virtual machine. That's something that you can easily do with the exam controls, and next time the grub boot menu will show up. Right, I'm going to try, and there we go. I press escape, and here you see the grub boot menu. In this grub boot menu, in the lower part, just behind the menu entries, we can see what we can do. I'm going to use E for edit, and I am going to start Linux. The line, this is the fourth line that starts with Linux. It's wrapped over three different lines. So this line starts with Linux and it ends with RHGB and quiet. I need to go to the end of the line first because I want to remove this RHCB and quiet. This line is the line that starts the Linux kernel with all the default arguments that are used while starting the Linux kernel. RHGB and quiet are hiding what is going to happen. I don't want to do that. I do want to add mem is 1G. You can probably guess what that is doing, isn't it? Next I'm using Control X, and Control X makes that it's going to start with this mem is 1G option. RM is asking if I want to modify the kernel. You don't want to modify the kernel itself. You want to modify the boot arguments. This is how you can pass specific boot arguments. RM, little bit of detail. You are probably asking this because in the early days of Linux, recompiling the Linux kernel was common. In kernels 2.0, we are talking about 1995 or so, the modular kernel was introduced. And because of the modular kernel, you rarely have to recompile kernels. The only thing you are going to do, you are going to load kernel modules using modprobe. And for the rest of it, the kernel comes with tunables, and these tunables are in the /proc file system. You might want to check out my Linux under the hood as well as my Linux performance class for more details about that. TL wants to know, how do we do the reset? Well, in the exam environment, you will have a specific control menu for your virtual machines on the exam desktop. And in that control menu, you will be able to reset your virtual machines. Hey folks, I see JS has a problem with the audio, and please let me know if you are also experiencing audio problems or not. I don't see anybody else complaining about audio, so I'm just going to continue. Why do we see this red hat screen? GC, I'm not there yet. I will answer this question, but not immediately. Thanks, MB, for letting me know that the audio is okay. Folks, I want to show you sudo -i. And okay, sudo -i, and I probably mistyped my root password. That can happen. So let me try that again. And free -m. Free is 2 E's. And what do we see? 679 megabytes of memory. Why is that? Well, I started mem is 1G. Why would you ever want to do that? Well, for testing. You want to figure out the ideal configuration for your system. Maybe you want to figure out how your system behaves if you started with a minimal amount of memory. And this is how you can do it. Mem equals, and you got the minimal amount of memory. Right, I don't like this minimal amount of memory, and I'm going to reset that pretty soon. But first, I want to get back to the slides a little bit. Folks, you know, double-click third button from the left if you need access to the slides. Now, what can we do otherwise? Oh, here on the slides, I'm already introducing systemd unit is emergency.target. What is emergency.target? Emergency.target is troubleshooting mode. And why would you want to do that? Well, because your system isn't behaving correctly. You know what? I am going to make a drawing for you. I feel this is something that I need to tell you about a little bit more. So let me show you the Greenland screen. It's my drawing tablet. and let me move the drawing application over the ice cap. There we go. What I want to do in this drawing, I want to give you an overview of everything that is involved in the boot procedure and take the opportunity of telling you a little bit about troubleshooting as well, because troubleshooting is a skill that you need to master for RHCSA. So how does it start? Well, it all starts with GRUB, the Grand Unified Boot Loader. If you don't see GRUB, well, then something seriously is wrong. Uh, GRUB is starting the kernel and the init RAM FS. Now, how does it work? Well, when you are installing Linux, the installation program is going to detect hardware devices on your system. It will load drivers for the hardware devices, and it will compile an init RAM FS. That's an initial RAM file system. And in this initial RAM file system, it includes all of the drivers that you need in order to work with your system. Then the next phase is that this thing called systemd is started. Systemd is your PID1. It's the starting point of everything. So what is systemd doing? Well, systemd, and I'm going to generalize it a little bit. First, systemd is going through the early boot. And the early boot is where it will initialize devices and mounts and other critical stuff. Once that has happened, systemd is going to initialize the services. And then you have a fully operational system and you get access to your shell. And that shell can be GDM, which is the graphical desktop. It can also be bash shell. Now that's a normal starting procedure. What can you do if something is going wrong? Well, if something is going wrong, there's a couple of things that you can do. Very first, you can use the grub to boot argument systemd dot oh sorry, I'm writing it a little bit too early. You can use the grub to boot argument, which is systemd dot unit is emergency dot target. The emergency target is a troubleshooting mode that starts minimal services, but it still starts with your kernel on your operating system, and it helps you to troubleshoot if anything is going wrong. Now, this emergency target is what you want to do if anything is wrong in the early boot phase. And if anything is detected to be wrong in the early boot phase while you are booting, you automatically get in emergency target. We have seen that in the demo that I started with yesterday, where I messed up my partitions a bit. etc fstep was referring to a partition that no longer existed, so the boot procedure got in panic and started emergency target. There is another target, and that is systemd dot unit is a rescue target. And what is the difference? Well, by the way, how I'm drawing it in, you should be able to guess what the difference is. A rescue target is going through the early boot and it stops before all your services are loaded. So a rescue target is bringing you further in your configuration. An emergency target is stopping earlier. We will later talk about another way to stop even earlier, and that is by telling your kernel, also in the grub boot boot menu, init is /bin/bash. In earlier versions of Red Hat Enterprise Linux, there was also rd.break, but rd.break is no longer a good option. That's RHEL 8. Don't use it on RHEL 9. On RHEL 9, you need init is bin bash. We'll talk about that later. Now, grub is starting your kernel and your init ramfs. This kernel comes with default options. You already know grub has the grub menu, and in this grub menu, You can also select the rescue kernel. What is the rescue kernel? The rescue kernel is a minimal kernel. What does that mean, a minimal kernel? Well, a minimal kernel means a kernel with the, the fewest amount. Is that proper English? I don't know, but you understand what I mean. With all special options turned off. The idea is if you start your kernel with all these special options and support for all your configuration, then you might get in trouble. And if you have a kernel related issue, you might want to start this rescue kernel. It can be an option as well. It's not something I commonly use for troubleshooting, but it's something that you can do. RM, no, but I will tell you what you do need to know. You want to know about the grub.cfg, not CNF. You don't want to know about all of it. It's useless. You don't go there, but I'll tell you about that later. I first wanted to tell you about these boot options. So there is one more thing that I should also include, just for completeness sake. This is not for RHCSA. If you do not get to the grub boot menu on your system, you can also always start from a rescue disk. That's what you just saw happening. My boot procedure could not find the grub code on my system, so it automatically got into the rescue disk. A rescue disk is amazing, but not something that we should explore in RHCSA. In RHCSA, all troubleshooting should start at the grub boot menu. And these are the options that I'm telling you about, just as a little bit of background information to what you see on the slide. May I advise, make a screenshot of this drawing, because you are going to like this drawing. It's a nice overview of when to use what. If you still haven't made the screenshot, be fast, because in 5 seconds I will show you another screen. 5, 4, 3, 2, 1, 0. That was 5 seconds. Do I have a new question? Yes, GC, a rescue kernel is not the rescue target. And good to hear that you already took the screenshot. I'm going back to my demo system, because that is definitely where I am going to be later. But maybe first some more slides. So we have this emergency target, we have the rescue target, and yeah, you can use C to enter the grub command mode, or E to edit the grub parameters. Entering C from the grub command mode, please don't do that, because that is bringing you the grub command shell. And I can tell you I'm lost on the grub command shell, because it comes with a specific command set, and I don't know this specific command set. So don't go in the command shell, but use E for edit to edit your default options. We'll get back to the grub boot menu in just a bit. If you want to edit persistent grub parameters, you edit the configuration file, and the configuration file is etc default grub. That's the only file that you can edit. Next, after editing your etc default grub, you write your changes to grub.cfg. It's an automated process. You never ever write grub.cfg yourself. And there's a very good reason for it, because if you update your kernel, while updating the kernel, a new grub.cfg is automatically generated to use the new kernel. And if you are automatically generating a new grub.cfg, guess what is going to happen with your old grub.cfg? It no longer exists. And that is why, really, you need to go to this etc default grub if there are any parameters that need changing. Now, on a BIOS system, which is the standard and which is what you are going to find on the exam. On the BIOS system, you write to /boot/grub2/grub.cfg. On a UEFI system, you are going to write to boot/EFI/EFI/redhat/grub.cfg. Now, I know what you are going to ask now. How do I know if I have a UEFI system? I would say let's have a look at the boot directory. And oh boy, I have an EFI directory, so that's not the good way. Probably use, I say probably, that doesn't sound very sure. Let me tell you in a way that is a bit better. Use mount pep pipe grep EFI. If you are on an EFI system, you have an EFI partition that is mounted. If you don't have an EFI partition that is mounted, otherwise, if mount pipe grep EFI doesn't return anything, then you are on a BIOS system. Uh, BIOS systems are the standard on the exam, and that is why it is safe to assume that you can write to slash boot slash grub2 slash grub.cfg. A little thing, and you probably don't care about it at all because we are not talking about Ubuntu here, but this slash boot slash grub2 slash grub.cfg is Red Hat specific. Ubuntu is storing it in slash boot slash grub.cfg. One of these annoying little differences between distributions. Now let me have a look at etc default where you can find very limited amount of files. etc default grub, and the etc default grub is showing me grub cmd line Linux. And this grub cmd line Linux defines how my prompt is showing. And this is where I can see this nasty RHGB and quiet. I don't want to see RHGB and quiet anymore. So I am going to remove it from here. There we go. I just removed it. What is next? Well, grub2 mkconfig -o slash boot slash grub2 slash grub.cfg. And then it generates new configuration file. And then when we reboot, we should automatically see it. This time while rebooting, I'm also going to show you how to enter troubleshooting mode manually. I want to avoid rebooting too many times. So if I reboot, I want to introduce something new. So here we go. It's rebooting. And there we have the welcome to grub. If you see the welcome to grub message, be fast. You have 5 seconds to press escape. So I'm selecting my default option, and look at that. In the default option, here we go. We don't have the RHDB and quiet anymore. So this was successful. I really don't like this RHDB and quiet. And whenever I have the occasion to enter this etc default grub and write new grub, I would always remove RHDB and quiet. I would say don't waste time on it on the exam to do this specially. If you have no business being in etc default grub, keep it that way. But if you need to be there, do yourself a favor and remove RHDB and quiet so that you can see error messages while they occur, not being hidden behind some graphical boot screen. I mean, graphical boot screen. Come on, are we on a desktop or what? All right, back to the terminal. And the end of this topic is approaching. You know what is after this topic, don't you? The mother of all topics, SE Linux. But first, a little bit more about booting in systemd targets. What is a systemd target? Well, a systemd target is a group of unit files. And that is kind of a lame definition, but I can't make it any more specific. It's a group of unit files. Hey, before moving on, let me type systemctl list unit files minus t target. Minus T in systemctl allows you to work on a specific type. That's exactly what I want. I want to see these target unit files. So systemctl list unit files minus T target. And here we can see all the targets that currently exist. Even the static targets which don't really matter. In fact, I think this is too much information. Let's make that systemctl list units minus t target, which is giving me what? Which is giving me an overview of the targets that are currently available. What I wanted to show you here is that we have units like sound.target. What is sound.target? Well, sound.target is just a target unit that was created to make it easy for you to start all the systemd units that are required for initializing your sound environment. And that's a convenient way because it makes it easy to do systemctl start sound.target, and all your sound stuff is initialized. Now, some targets can be used to define the initial state of your system. And we don't see them here. And to make it easier, I've put it on the slide, so please have a look at the slide. These targets have the isolate option. It's an option that you will see if you use systemctl cat on your target file. You will see isolate is true. And these are emergency target and rescue target. You already know what these are about. Then there is multi-user target and there is graphical target. Now, what are these? Well, simple. Multi-user target and graphical target are the normal targets that are used to boot your system into a specific state. Multi-user is what you will find on a server without a graphical user interface. Graphical is what you will find on a system that does have a graphical user interface. And yeah, you can even change these targets if you want to. Now, for your RHCSA, you need to be able to set and change your to get and set your target. And how is that happening? Well, systemctl get default is showing me that I'm in graphical target, and systemctl set default multi user.target would set the multi-user.target as the default. And what is going to happen next when I reboot? Well, hopefully you can guess it, but this time we are going to sit it out anyway. Just pressing enter. I have no business being on the group boot menu this time. And it's going to start multi-user target. And as you would have guessed, in multi-user target, there is no graphical user interface coming up. So we just have this prompt. So logging in as user student with my very secret password and sudo minus I. And I am rapidly going to use systemctl set default again, graphical.target. And I'm going to use systemctl isolate graphical.target. That is the command systemctl isolate. That's the command that you can use to switch between different targets. So if right now you are in multi-user and you want to activate graphical, well, systemctl isolate. And that's bringing me back to the graphical target. Let me get back to the terminal. I think I'm almost done with this topic. And let's see what is next. Booting into a specific target. We have already seen that systemctl.unit is whatever.target as a group boot argument. I've already shown you how you can use it to get into emergency mode, and we will certainly see it again. Systemctl isolate is what you can do to change your current target to a new target that you want to be working with. And you know what? Up to now, we have done so many breaks combined with the lab. That's exactly what we are going to do now. So I feel this is worth a 13-minute break. So go get yourself some coffee. When you are back, configure your system to boot in multi-user target by default, and persistently remove the options that hide startup messages while booting. I know that if you are in cloud instances or in the O'Reilly sandbox, it might be a little bit hard because cloud and O'Reilly sandboxes have their own boot procedure. That's something I don't want to talk about that because that is only confusing for your RHCSA. So there's a chance that you can't do that. If that is the case, then I would just say enjoy your additional minute of break time. Uh, Let me type history and open a little terminal. And in this little terminal, I will start the countdown and make it 13 minutes. Enjoy your break. Talk to you in a bit. Hello, everybody. So it's time for what? Well, what do you think? Security enhanced Linux. Uh, Let me start with some slides. So, what is security enhanced Linux? Well, security enhanced Linux is an additional system that can be used for security. Uh, and why do we need it? Well, we need it for the simple reason that Linux security is built on Unix security. And Unix security was developed since the original introduction in the early 1970s. And the problem with Unix security is that it consists of different solutions that were never developed with current IT security needs in mind. Unix security is taking care of different parts of the operating system, but it doesn't consider everything that is involved, and that is problematic. And for that reason, there is SE Linux, and SE Linux provides a complete and mandatory security solution. So if you want to make your Linux distribution bulletproof, SE Linux is what you are going to need. SE Linux is about what an application can do. So you have an application, applications access files, okay? And SE Linux is what you are going to configure to define which files can be accessed by an application, which network ports can be accessed by an application, and such. SE Linux, let me be clear about it, is not the same as a firewall. The purpose of a firewall is to regulate incoming traffic. The purpose of SE Linux is to avoid unauthorized actions. And the default situation is that in SE Linux, if it's not specifically allowed, it will be denied. Now that sounds like something that makes your system quite complex when SE Linux is involved. The good news is that SE Linux comes with a policy, and in this policy, all default activity of services on your system will be allowed. But unknown services will always need additional configuration to enable them in an environment where SE Linux is enabled. And that is what people don't always like about SE Linux. But the fact that people don't like SE Linux in most cases comes forth of ignorance. Now, folks, I am going to tell you about SE Linux for 1, maybe 2 hours in today's session. After today's session, there is more to learn. There is a recorded video course about SE Linux as well. I will pop up a link later today. If you need additional studying, I can warmly recommend you study the recorded video course. But once again, let me repeat what I just said. Known services work well with the standard SE Linux configuration. Now, when you work with SE Linux, the very first thing you need to know about is the SE Linux states. So SE Linux is either on or off. And when SE Linux is on, we call that enabled. Then SE Linux is enforcing or permissive. In enforcing mode, SE Linux is fully protective. In permissive mode, it is only logging. Everything is allowed, nothing is blocked, and it is only logging. Switching between enforcing and permissive is very important for troubleshooting SE Linux, and that is what we are going to do a lot. So you can use get enforce to show the current state. You can use set enforce to toggle between enforcing and permissive. And you can use SE Linux is 0 as the wrong option. If you use SE Linux is 0 as a grub kernel boot argument, you can set SE Linux to disabled. Let me be very clear about it. Never set SE Linux to disabled on your entire duration of your exam. Sometimes people think, yeah, it's so much easier to configure my system without SE Linux. Well, switching your system to SE Linux is disabled is a pretty bad idea. That's because in disabled mode, you get different behavior than in enabled mode, no matter if it's enforcing or permissive. And once you get out of disabled mode, you might have to do some additional troubleshooting. You don't want to get there. So don't you ever use SE Linux is zero, please. Now let me do a quick demo and show you what's going on. So I'm using get enforce. Get enforce is showing that I'm enforcing, and I'm using set enforce. And using set enforce, I can switch to permissive. And now get enforce is showing that I'm in permissive mode. Permissive mode is not blocking any actions; it's still logging. That's very important for troubleshooting. Once you have done whatever reason you had to get into permissive mode, use set enforce and forcing again to get back to enforcing mode, because that is the mode in which you want to be. Also on the exam, if you leave your exam virtual machine in SE Linux permissive mode after a reboot, or in SE Linux disabled mode, that is going to cost you serious amount of points. So don't do that. Now, how do we manage SE Linux states while booting? Well, you can do that using a kernel parameter. Again, you don't have to do it, because SE Linux is automatically enforced, and that is what you want to happen. So kernel parameter enforcing is zero. Don't go there. Enforcing is one, is the default. It's embedded. You don't need a specific parameter to enforce it. Likewise, for SE Linux is zero and SE Linux is one. You will get an enabled SE Linux mode, but that's the default mode. I repeat, there is no reason to change whatever. Now, in SE Linux, there's a couple of components. And the most important component is the context label. What is a context label? A context label is a set of specific permissions. And context labels are applied to source objects and target objects. Before I continue, I'm going to give you a quick demo. So let's have a look at my system. I am going to use PS ZAUX to get an overview of all context labels that apply to processes. That's a lot of information. In fact, that's too much information. Let me filter it down a little bit, and let me use PS ZAUX pipe grep HTTP. What do we see? We see the HTTPD process. You remember yesterday I installed HTTPD and I enabled it in systemd, so it is running. And we see the context label, and the context label is what you see in the beginning of the output. It is the option uppercase Z, which is showing context information. This option works for many commands, so generically, if you want to display SE Linux related information, use uppercase Z to show what is going on. Now, next, you can see that in this context label, there are four different parts. Part number one, system underscore U. What is this system underscore U? That is the user context. And I have good news about it. You don't have to know anything about it for the exam. Likewise for system underscore R. That is the SE Linux context role, not relevant for RHCSA. The only thing that is relevant is the third part. That's the context type. In RHCSA, you only look at the context type. So the context type is set to HTTPD underscore T. And this context type is used in the policy, because in the policy you have rules that allow a source context to access a target context. The last thing, the S0, that's a security label, also not relevant for the RHCSA exam. You want to know all about users and roles and security clearances, watch the recorded SE Linux course. I hope you are going to think it is pretty awesome. But for RHCSA, focus on the context type. RM, be patient. We will get there. I'm not ready for SE Manage yet. You first need to understand what you are doing, And then we can talk about SE Manage. Of course, we are going to talk about SE Manage because SE Manage is the default tool to manage anything SE Linux. We'll get there. But first, let me show you ls-z in var www. What is that? That's showing context types on directories. And what do we see? We see that we have a CGI bin directory for HTTPD. That is the directory where you would put scripts. And this has the context type HTTPD sys script exec underscore t. We have the HTML directory. That is where you would put your documents, your read-only content, and there you have HTTPD sys content t. Now, the thing that is interesting to see here is that apparently we can differentiate by context labels. So we have a context label that allows script execution, and we have a context label that allows you to read files. And there are many more context labels. But this is what is going on for SE Linux context labels. When a process is trying to access a directory, SE Linux is going to check the context labels. So SE Linux is going to check, hey, what is the source context? And oh, the source context is HTTPD underscore t. It is trying to access HTTPD sys content t. Then SE Linux is going to check, do we have a rule in the policy that allows such access? If the answer is yes, nothing's wrong. If the answer is no, then you will get an AVC denied. We'll talk about AVC denied specifically later. Now, what is the result? Well, the result is that if you decide to reconfigure your Apache server so that it services files from a non-default directory, that you have a context label mismatch. And that is the example that I want to work out in much detail now. Folks, I'm going to start a big demo. I know in classes like this, people like to do multitasking. This big demo doesn't go together with multitasking. So please, can I have your full concentration while I'm still in this big demo? So the first thing that I'm going to do, I'm going to change my Apache configuration so that I can show you what SE Linux is doing if these context labels don't match. Second part of the demo, we're going to fix it. So what do I want to do? I am going to give you, I'm going to configure a non-default document root. Folks, for this topic, I'm not going to answer one single question that is not directly related to what I'm talking about right now. I want to finish my story because once I finish my story, you have basic understanding, and then I can answer other questions. So if you have questions, it should be related to something that I'm typing. It should be directly related. Please hold off questions about anything else that you may have heard about, because yeah, I can't answer it as long as I haven't explained everything, so that everybody can understand what is going on. So I'm going to create a custom document root in the directory /web, and I'm going to create a file /web/index.html. And in that file, I'm putting hello world, simple message. That's simple enough, doesn't have to be any more complicated. Now, of course, I need to tell my Apache server to use this non-default document root. How am I going to do that? By editing etc httpd conf httpd.conf. Folks, what I'm showing you right now is needed for my demo. For the exam, you do not have to be able to reconfigure Apache document root. But I need an example that makes sense. This is the example that makes sense. So etc httpd conf httpd.conf is where I'm going to change my document root. What do we see? We see the document root is set to /var/www/html. I am going to set that to /web. Now, another thing that I need to change here is the lines, a couple of lines below, just behind relax access to content within var www. This is Apache configuration. You do not have to know about it, but in order to make my demo efficient, I do need to change the Apache configuration as well. Because you know what is going to happen otherwise. Well, otherwise, you would have the Apache server blocking access. And then you are not troubleshooting SE Linux, you are troubleshooting Apache. That doesn't make sense. So I need to tweak this Apache configuration as well. So here we go, directory/web. Next, I change the Apache configuration. So I need systemctl restart HTTPD so that Apache picks up the configuration. And now we are going to do our fun part. And what are we going to do in the fun part? Well, I am going to use curl to localhost. If you've never worked with curl before, curl is a command line browser. And for what I want to do here, a command line browser is all I need. I want to do a quick and dirty test and see if it is working. So I'm trying to get access to localhost using curl. And we see a lot. I don't see my hello world message. What does that mean? Well, that means obviously that it's not working. And yeah, what are we going to do about it? Well, we need to fix it. Now, this is a situation, this is a starting point that we need to fully understand. You have a configuration, your configuration is not working, and you need to be able to analyze. How are you going to analyze? You need to figure out if SE Linux is involved, yes or no. Now, how are we going to do that? Well, the easy thing, and this is always the first thing that you should do on the exam as well, you should figure out if it is denied because of SE Linux or because of anything else. How are we going to do that? Well, set enforce permissive. That's what you are going to do. So now that I have set enforce permissive, I am going to repeat my curl command again, and we need to figure out if this time it is working. And yes, this time it is working. And this, without any doubt, is all the proof I need to confirm that it is SE Linux blocking access and nothing else. So if at any time it doesn't work, you use set enforce permissive. If suddenly it works, then it is because of SE Linux. Now your next mission is to get immediately back to enforcing mode, especially if you are doing this on an operational server, because in permissive mode you are vulnerable. You don't want to be vulnerable, you want to be protected. And we are going to analyze what is going on. How are we going to do that? By using grep avc on var log audit.log. SE Linux messages are written to the audit system. Audit daemon is a part that should be present on your Red Hat Enterprise Linux system, and that is where all SE Linux denials are logged. And SE Linux denials are logged using AVC. AVC stands for Access Vector Cache. And you get this AVC because SE Linux is trying to get information about the Access Vector Cache. And this is what you are going to do to figure out what was going on. And what do we see? We see messages like AVC denied for PID 4745, command is HTTPD, path is index HTML. This means, the part that we see here, this means that SE Linux is not okay giving your HTTPD process access to index HTML. Now, before we are going to look any further in the AVC output, we are going to do the obvious thing. And that's the following. ZAUX pipe grab HTTP is showing the HTTP processes. ls minus z on var, no, not var /web /index HTML. And what do we see? We see that HTTPD has HTTPD underscore T as, as its context. That's expected because we didn't change that. And we are trying to access a file that has default underscore T. That's the problem. Now, what you need to understand here is what you need to do. We have two options. Option number one, we can add a rule to the SE Linux policy. And that could be a rule where we are going to allow source context HTTPD underscore T to access target context default underscore T. That's a very bad idea because the source context HTTPD target context default underscore T is uncontrolled. So if you would add a rule that allows HTTPD to access the target context default underscore T, that's a bad idea. The only right solution is to change the context on this web index HTML to something that works for SE Linux. And that is what we are going to do next, using SE Manage. JS has a question. And this is a question that's directly related, and that's why I'm answering it. In case you feel like, hey, you didn't answer my question, you do answer JS's question. Yes, it's because it's directly related. And the question is, why do you check the audit log, and why don't you use AU search? I don't use AU search because AU search is only a tool to log in to look into the audit log. The audit log, that is where the messages are written. If you use AU search is interpreting the content of the audit log. I can interpret better. I like to go directly to the audit log because the lines in the audit log are not so complex. Let's get back to the line in the audit log. Grab AVC, this line. Let's go there bit by bit. We have type is AVC. Type is AVC. That is what you will see for all SE Linux denials. Then we have an audit ID. This is a timestamp. Time in epoch. And this time in epoch is unreadable. But hey, I don't care about the time. I see this last in my list. And I can easily relate this to what I've just done. So yeah, I know you can use date minus B at epoch. And that will print the timestamp, and that is giving you the real time. Is that important? No, it's not. Then we have AVC denied. This is what SE Linux has done. Then we have map. Map is like the system call that was executed. And we have for PID 4745 command is HTTPD path of web index HTML. This is the essence. SE Linux has blocked access for HTTPD to index HTML. Then we get the device that was involved, even the inode, and we get source context and target context. So source context is HTTPD underscore T, target context is default underscore T. And you can also see permissive is one. This message is logged in permissive mode. What I want you to do, I want you to read this because too many people on RHCRZ are focusing on so-called useful utilities to analyze what is going on. But I can tell you a secret. If this utility isn't working, you can't use it. That was 10 seconds of impressive silence. I'm not sure if it was 10 seconds. Let me repeat what I just said. If the utility you want to use isn't available, isn't working, you can't use it. And what do you want to do? Do you want to waste your time getting utilities to work that you don't need if you understand what is going on? Or do you just want to get it from where it is written to, understand what is happening, and work from there? That's a self-answering question, I hope. AS is asking, what if the audit log is not present? AS, if the audit log is not present, then you are going to do this. You are first going to do a systemctl status audit B. You should see it active running. If it's not active and running, you are going to do dnf install -y audit B. And is that audit? Yeah, it's audit. It's the audit package. Make sure that the audit package is installed. Make sure that the audit B service is enabled and running. In case it is not, enable it and run it and repeat what you were just trying to do and where you suspect that SE Linux is involved. Now, where you know that SE Linux is involved, because at this point, you already know enough to determine whether or not the failure of what you wanted to do is because of SE Linux. I hope that makes sense, AS. And B is asking, it will be on exam. And B, if that is about SE Linux, I can only tell you, no, I just like to waste about 2 hours of our precious time together on a topic that is not on the exam. A and B, that is not a very useful answer, but by now I really expect you to know how to find the exam objectives. By now I already expect you to trust me on the content that I'm delivering and my mission not to waste any time on topics that are not relevant for the exam. Okay, now back to the point. We have now found out that this problem is because of SE Linux. And let me get back to the line. The line is really where we have this source context httpd_t trying to access the target context default_t. And this target context is going to the target context is wrong. Yeah, and B, it was answered to question about presence of audit. Well, if you are answering questions about presence of audit on the exam, you are violating your NDA, and I can only kindly and politely ask you not to do that. My courses are not a free place to violate the NDA. My courses are courses where you learn how to pass the exam. RM is giving an error message. RM, tell us at least what you are trying to do. I don't know what you are trying to do. So just posting error messages like this is useless. If you want some help on it, please give us context. Everybody, I want to get back to the point. So I am going to ignore all questions that are going to be asked right now until I'm done with the next part of my demo. And what is the next part of my demo? Well, the next part of my demo is what are we going to do about it? We have just seen that httpd_t is not allowed to access default_t. What are we going to do about it? We need to set the right context. How do we find the right context? Different solutions. Let's go for the easiest solution. The easiest solution is to check default environment. Hey, HTTPD has a document root. Let's check what is on the document root. ls -lz on /web. No, not /web, /var/html. Is showing that I made a typo. Sorry for that. And var HTML, var www. My mistake. I do apologize. What do we see? We see HTML, and we see the context type that is set on HTML. HTTPD syscontent key. Now that is part one of the answer. Part two of the answer is how are we going to set it? That is where SE manage is involved. Your main utility for fixing SE Linux related stuff on the exam is SE manage f context. Now, may I give you an advice? SE manage f context has a beautiful man page. Man SE manage f context. Try without the DRM audit, not audit D. Man SE manage f context. Use uppercase G to go all the way down in the man page, and there you see some lovely examples. And guess what? This is the example that we are going to need. As you manage F context, that's how you can manage your own file contexts. Minus A for add, minus T for type. The type that I'm setting is HTTPD syscontent T. And I am going to set it to /web with this weird thing behind it. What is this weird thing behind it? That is a regular expression. I don't want to explain the regular expression. I want to summarize it. It is going to set the HTTPD syscontent underscore T context to the directory /web and everything that might exist within that directory. So let me just copy it. I would advise against copying, by the way. If you type it, the more you type it, the more likely it is that you are going to remember what is going on. So I am going to paste it now, and I'm going to run my command. Now, before I'm continuing, what is this command doing? This command is writing a new context to the SE Linux policy. So we are writing to the SE Linux policy. Nowhere else. What does that mean? That means that if at this point I'm using ls minus dz on /web, we still see default underscore t, and that is correct. Because if you write a context to the SE Linux policy, you don't automatically make it effective. And that is what we are going to do next. We need to make sure that this policy is effective. And in order to make it effective, there's a second command. Restore con. Restore con minus rv on /web. The restore con command is checking what is in the policy, and it's applying the settings from the policy to your file system. And here we can see that it has relabeled the file system. Now, this is an important one. If you are working with SE Linux context on file systems, you first write the context to the policy, and then you apply the context to the file system. So two commands are involved. SE manage F context first, restore con next. And now if I repeat my ls minus dz on /web, we can see that /web has httpd syscontent t. And let me do a get enforce. And get enforce is showing that I'm in enforcing mode. And what I really want to do, I want to repeat my curl command. I don't know if you know this construction exclamation mark CU will repeat the last command from history, which is CU, which is curl, and curl is giving me hello world. What does it mean? It means that at this point we are fixed. We are done. OA is asking, what if SE Manage is not installed on your device? OA, if SE Manage is not installed, you need to install it. And behind your question, OA, is a question, how do I install a package that is not installed? Well, I would say the best method is DNF provides. So DNF provides /SE manage is querying the package database to see which package contains the SE manage files. And that is policy core utils Python utils. I can see it's on the repo add system, and this repo add system, well, that means that it is installed. So policy core utils Python utils is the package that you need to install. And if it's not installed, well, it's in the AppStream repo, and you need to install it. I'm not going to do it here because it's already there, but this is what you need to do. This is pretty important, folks. DNF provides is one of the most important commands that you need to know about for the exam. I would say for your exam, there's a couple of very basic essentials, and DNF provides is one of the very basic essentials. OV is asking about a regular expression. Let's get back to the regular expression. What is the regular expression? Here we go in command 381. So /web. Then between the parentheses, we have stuff. and the stuff is followed by a question mark. Question mark is an extended regular expression, meaning that the preceding stuff should be present 0 or 1 time. That means that we may have stuff behind slash web. We also can have no stuff behind slash web, and both situations are okay. Then we need to analyze the irregular expression itself, which is about a slash. Uh, Slash is just a slash, no specific meaning. A dot. A dot refers to a single character, and the star. And the star means 0 or more times. 0 times, that is because it matches on slash web slash. Next, behind slash web slash, we have other stuff. MB is asking, would slash web star work? No, it doesn't. It's a limited regular expression, so don't do it. And hey, folks, let me get back to the solution. Man, as we manage F context, this is showing how it works. I would say don't think about the meaning of regular expressions on your exam. Really think about what you see in SE Manage F context. How should you interpret? You should interpret here. I have a nice example of how to set an SE Linux context on a directory, including all of its contents. I would say whenever you are going to set an SE Linux context on a directory, use this regular expression and don't think any deeper because it will work and that is what you want. Now, the other part, that's the part that we need to further investigate. What if it's not so obvious what the context is that you are going to need? We'll talk about that later. But first, I'm going to show you the history again so that you can contemplate the commands that we have used, and we are slowly going to move forward. I'm not done yet with SU Linux. I'm very aware that there's still a couple of questions unanswered, but I want to stay close to the slides because maybe that is going to help you to find the answers back when you are studying for SU Linux for yourself. Hey, we were still talking about exploring SU Linux components. So SU Linux works with source objects. Source objects are users or processes, and the target objects are files and directories and ports. We will talk about port security later. I have a separate example about that. But first, I want you to understand this file security. Now, SU Linux policy has many rules to define which source context has access to which target context. So many rules. We are talking about approximately 10,000 rules. It's so many rules that you don't want to print a list of all of these rules. You want a smarter way to analyze what is going on. And that is what will become clear as I continue explaining SU Linux. Good. How do we manage SU Linux? Well, context management is the most important thing that you are going to do. And context management is where you are going to apply context to mostly files, directories, and ports. We have seen an example where you do it recursively on a directory. If you do it recursively on a directory, it applies to the files as well. Ports will be coming up later. So you'll need to apply a context that matches a specific rule. And booleans are another part of SU Linux. These are easy switches to enable or disable specific functionality. That's something I will talk about separately later. But first, let's zoom into the context labels. Hey folks, in case you think, Sander, you just explained that, then you're on the right track. But I know that SU Linux is complex if you hear about it for the first time. So I'm repeating stuff a little bit so that you can think about it some more. And if anything is not clear, you can ask questions about it. So context labels. Every object is labeled with a context label, user and role and type. I already told you type is the only thing that really matters for RHCSA. So ignore user and role. We have also seen that many commands support a minus uppercase Z option to show current context information. And context types are used in the rules in the policy to define which source object has access to which target object. Oh, wow. What does that mean? Well, that means that in the policy, these context type, this HTTPD sys content T stuff is important. That's all that it means. Now, how about default file context? Well, most services on Red Hat don't need additional SE Linux configuration if the default settings are used. What does that mean? That means that if you are going to install HTTPD and you are using default configurations like default document root, you don't need to do anything. This is for people who are saying, well, on Red Hat Enterprise Linux, first thing I'm doing, I'm switching SE Linux off so that it's not bugging me anymore. You don't have to do that because if you're using default configuration, it all works. And when files are created in a directory, typically they inherit the context of the parent directory. There's an interesting thing here, folks. And the interesting thing, I will illustrate that with a demo before we go on a break. The interesting thing is if you create a file, it inherits context from the parent directory. If you move a file, it doesn't inherit context. And that is because if you move files, all properties of the files are moved alone. I am going to demonstrate that, and that will be a nice thing to think about. So when files are copied, they typically inherit the context of the parent directory, and when files are moved, they keep the context. So moved files are problematic, copied files are not. Now, how do we manage file context label? Let me repeat what we have just seen about SE manage. We have the SE manage fcontext command, and the SE manage fcontext command will set the file context label. This is the most important command that you are going to work with regarding SE Linux on the exam. SE manage fcontext. So if you use SE manage fcontext, as I have just explained, you will write the context to the SE Linux policy, but it is not yet written to the file system. You can use SE manage fcontext -a to set a new context label, and you can use SE manage fcontext -m to modify an existing context label. But in both cases, if you do that, the new context will not be written to the file system. SE manage fcontext writes to the policy. That's important to realize, because SE manage fcontext is not enough. That's what I've shown you, and if you go back to man SE manage fcontext to the examples all the way to the end, then you can see that it's very clear about it. First, you need to remember to run restore con after you set file context. So I'm going to repeat this probably a couple more times. You really need to remember to run restore con after setting file context. This is important because otherwise it doesn't work. Now, what's the difference between SE manage fcontext -a and -m? You use -m if you get an error message context already set while using -a. And we have just seen a restore con is how you enforce policy setting on the file system. There's another way, and that is touch/.auto-relabel. Touch/.auto-relabel is something that you should only use in troubleshooting scenarios. What is a troubleshooting scenario? Well, you have been in emergency mode or in some other mode where SE Linux was not fully protecting your system. If you are in a situation where SE Linux is disabled and you change files, the context of these files will be messed up. And if next you boot in normal operational mode, and in normal operational mode SE Linux is enabled again, then all these messed up context files don't work anymore. So that's a very bad situation. And that's why I just told you, never change your system to disabled mode, because you might severely mess up your system. But there is a solution, and the solution is to create a file touch/.auto-relabel. But I can tell you, I have seen touch/.auto-relabel failing to restore the original context in an easy way after it was messed up too much. So I repeat my previous point: do not set your system to disabled mode unless you really need to for urgent troubleshooting. In very rare cases, it is unavoidable. In most cases, you can avoid it. And if you need to do it, touch/dot auto relabel. Before today's session is over, we will see how touch/dot auto relabel can be handy. So we already know that man, as he managed F context, has nice documentation on how to use the command. If ever you hear somebody about chcon is a very bad command. Don't you ever use it. If you have questions about it, please ask. But if you don't know what chcon is, then I would say that's good. Let's keep it that way. You don't want to know what chcon is. It's a bad command. I have a fun story about it, so if anybody asks, then I will tell you the fun story, but for now, let's not do that. Also nice for troubleshooting is if you use semanage fcontext minus L minus C, then you will see settings that have changed in the current policy. That can be interesting. semanage fcontext minus L. Minus L is showing all contexts. By the way, how many contexts do we have? WC minus L for word count word count all lines. Oh, that's only 6,824 lines. That's a lot, isn't it? So minus LC is showing. Oh, my mistake. Minus LC is only showing the contexts that have changed. That can be useful if, for some reason, you messed up stuff and you don't remember what you did anymore. Then this command can show you the changed contexts. Okay, I'm still not done explaining SE Linux, but it's time for a break. I like to do a break in the middle of my SE Linux explanation, and I want to do a quick demo, and the demo will ask it a question. So I'm going to do something, and I'm going to ask you, how are we going to fix it? So let me do CP. Let me think about it. No, let me do vim/root /hello. And hello from SE Linux Heaven, because it's a heavenly solution. I hope you agree with that. I'm using ls minus z on the hello file. It happens to be in my current directory. What do we see? It has admin home underscore t. I am going to move the hello file to the /web directory. That's my new document root, remember? And I'm going to use ls minus lz on /web. I want to see the context. And what do we see? We see index HTML. Index HTML is good. And we see hello, and hello is not good. Let me use systemctl restart httpd. You know, sometimes I'm also not sure whether or not I need to restart my service. Then I have a very easy solution. Let's just restart the thing. In case it is required, at least I'm sure that we have done it. So I've just done it, and I am going to try to access curl localhost /hello. And is that working? No, that's giving me a forbidden. What is going on? Well, how are we going to analyze? Please remember, how are we analyzing situations like this? You are going to use grep avc on varlog audit.log. And what do we see? We see an AVC denied. You can make it easier, remember? In order to make it easier, you would first use set enforce permissive, then you try again. You would see that it works. And I'm bypassing that also. I directly want to dive into the audit log. And in the audit log, we can see that we have the AVC denied. So we have an SE Linux problem. Here is the question. How are we going to fix this problem? I will give you a little bit of background knowledge. The background knowledge is that I just move the file into the slash web directory. Do you remember the regular expression in the slash web directory? It applies to slash web and everything that is created in the slash web directory. And the question is, how are we going to fix? And the answer, yes, TL, you are going to fix it by using a restore con. Because this file should inherit the context from the directory. So I'm using restore con slash web slash, that's not a slash web slash hello. And then I'm using exclamation mark CU, and there we go, hello from SU Linux Heaven. How it works. That is how easy it is. This was very easy, wasn't it? Yeah, I would say let's do a break and let's continue after the break. I have no labs during this break. You might want to play around a little bit. I do have a lab, but I think the lab should be done after this session. If SU Linux is new to you, then you really need to practice after today's session. Up to now, I've not given you homework. Today, you will get homework, and that is practice this stuff. But first, let's do a break. The break is 12 minutes, and I'll see you in 12. Enjoy your break. Hello, folks. Good to see that you are still here. So, we now know about SE Linux. We know how to troubleshoot SE Linux. So, if you think that SE Linux is involved, you use set and force. First, get and force to see in which mode you are, and next you use set and force to go into permissive mode. If it then works, then obviously it was because of SE Linux, and you can do your further troubleshooting. Troubleshooting should always start in the audit log. I'm going to tell you about useful tools shortly, but that doesn't replace the need to look in audit log because you need to understand what is going on. And based on your understanding, you can do the best troubleshooting and nothing else. If it is a file context, you have SE managed F context. SE managed F context writes to the SE Linux policy, and you use a restore command to apply settings from the policy to the file system. Two commands are needed. What we don't know yet, and which we are going to talk about now, is how are you going to find the right context? Well, there's a couple of things that you can do. I told you before, if you don't know which context to use, the best way to go is to check the default configuration context setting. What does that mean? Well, as we have seen in the case of the web server document root, you have a default document root. Check out the default document root and see what it is set to. Also, and that's a new one, you can read the man pages from SE Linux policy doc. SE Linux policy doc. Well, let me tell you something. DNF list SE Linux star. What was that again? Well, I am pretty sure that many of you don't remember the name of the package on the exam. And the easy way to find the name of the package on the exam, if you don't remember, is use use DNF list SE Linux star. That will show you all packages that have a name starting SE Linux, including SE Linux policy doc. So let me do a DNF install -y SE Linux policy doc, and not dic, it's doc. That will install all of the man pages for every single service that you can configure in SE Linux. And it will be a lot. Use man -k underscore SE Linux because all of these man pages end in SE Linux, and there you can see a list of all the man pages. And in case you do want to know, pipe WC-L is showing that there's no less than 876 man pages. Now, how does it work? Well, pretty simple. These man pages have names like service underscore SE Linux. But hey, in case of doubt, you know how to grab it, right? So if you're not sure, just grab it. Well, I am sure, so I'm not going to grab it. I'm going to show you man httpd underscore SE Linux, for instance, which is the man page for SE Linux. Now, what you need to know here is that the result is gonna be impressive. Commands like this are showing a lot of results. And because commands like this are showing a lot of results, I'm just scrolling through without making any comments. You need to know what you are looking for. I can tell you, if on the exam you are going to need the man page to find what you need to do, you are going to fill your assignment. These man pages are interesting, but I don't think you are going to use them on the exam. I mean, look at all the different context types. Look at all the different booleans. Yeah, I know I haven't yet explained booleans. We will get there. My message here is these man pages are giving too much information. So this is not the best way. The best way still is to look at the default configuration. I repeat the point I previously made. There is also SE Alert. And I know right now some of you guys are thinking, Sander, why didn't you start with SE Alert in the first place? Well, that is because SE Alert is a bit problematic every now and then. So you should start working from your understanding. Then you are going to investigate and to confirm what you figured out while investigating. You can use SE Alert, but we don't start with SE Alert because you will be SE lost if that is the only thing that you can do. That's also why I'm not yet going to talk about it. I first want to talk about port context. Now, what is the thing? The thing is that network ports are also provided with an SE Linux context label. And if you are trying to run a service on a non-default port, that is not going to work. So SE Linux policy is is configured to allow default port access. And if you want to do anything that is non-default, you start by using SE managed ports to apply the right label to the port. And here again, the man page is really helpful. Man SE managed -port as examples. So let's check it out. Man SE managed -port and do an uppercase G. And what do we see? SE managed port -L. If you care about listing all current port definitions, I can tell you a secret, probably not. And here you can see how you can use this command to allow Apache to listen on port TCP port 81, or allow SSHD to listen on TCP port 8991. And in case you are wondering, where is a restore con? Well, I can tell you SE managed port does not need a restore con. Restore con is for the file system. So restore con is needed because you write the new policy, the new rule to the policy, and you need to apply it from the policy to the inodes table. The inodes table is the file system administration. Ports don't have an inodes table. So your port context is directly fetched from the SE Linux policy. And that's why there is no restore con involved. Let's do a quick demo. I am going to edit etc sshd underscore config. And there we have port 20, and I am going to change my port 20. I will make that port 2022. Did I say port 20? I meant port 22. Sorry for that. I am going to restart SSH. Systemctl restart SSHD. And it's failing. If you get a message like this, you can investigate why it is failing using systemctl status on the service. And what do we get? Oh boy, I'm only getting a code, an exit. It's not really telling me anything that is useful. Okay, how about journalctl? Let's follow the suggestion. Journalctl -xeu sshd.service. That's how you can filter the journal and sshd.service. And this one is pretty clear. To be honest, I'm a little bit surprised that it doesn't show it with systemctl status on SSHD. But I can forgive the systemd because it printed a clear message that directed me to this command, which is showing what is going on. So bind to port 2022 on 000 failed, permission denied. What are we going to do next? Well, depending on what you want to do, I'm pretty sure that SE Linux is involved. And as I'm pretty sure that SE Linux is involved, I am going to investigate. Grep avc on var log audit.log. And I'm just having a look at the last line where we can see ABC denied name bind. Name bind is where a process is trying to bind to a TCP or UDP port, where we have the target port, and the target port is set to unreserved port _t. So what are we going to do about it? Well, hopefully, based on your knowledge of SE managed port and the beautiful help that is available, you know what to do about it. So man SE managed -port uppercase G, and I am going to copy this command because it only needs a small modification. Copy and paste, and changing the TCP port to 2022, running it again. And then I'm going to run my systemctl restart SSH read, and now it doesn't complain anymore, and that means that it should be offering service. So systemctl status on SSHD is showing that the server is listening on port 2022, and that is how it works. I hope it's becoming a bit clear, but I'm still not done. I have two topics remaining, two short topics. First topic is the Boolean. What is a Boolean? A Boolean is an easy-to-use configuration switch, and you use it to enable or disable specific parts of SE Linux policy. There's a limited number of Booleans, and that is why you might want to work from a list of Booleans. So SE manage Boolean -L is showing you the Booleans. And in cases like that, I would always use WC-L, and WC-L is showing only 355 lines. That is not too much, isn't it? And as this really is not too much, you might want to go for a different approach. Maybe you just want to grab on it. So as you manage Boolean -L, grab FTP, for instance, is showing what? Is showing that there's a Boolean like FTPD anon write. That's the Boolean that denies anonymous FTP writes. So because of this Boolean, no matter what you are going to do in your FTP configuration, SE Linux is going to deny. What are you going to do if ever you want to allow functionality like this? Then you are going to use setSebool. That's a shortcut. Set SEBool -P for permanent of FTPD anon write. You set it to on. And now the SE Linux Boolean is on, and we can verify that, and yeah, it is on. So that is how easy it can be to work with SE Linux Booleans. Really nothing else to say about it. Booleans are not a thing to focus on in the RHCSA exam. SE manage fcontext, SE manage port, that's the stuff that you want to focus on. But sooner or later you will come across a message about Boolean, and it's really one of the key ingredients of SE Linux. So you need to know how it works, and well, hopefully now you do. All right, back to the slides. I'm almost done with the thing called SE Linux. We just need to talk about SE Alert. So what is SE Alert? First and foremost, SE Alert is something that might not even be installed on your exam. I said might, okay? That means that I'm not disclosing any sensitive information, just in case you wonder how this is compatible to the NDA. And if the SE Alert is not installed, well, you first need to install it. And that for a tool that is not always that useful at all. Think about what you want to do with it. So SE Linux uses auditd to write log messages to the audit.log. And some people think that these messages are hard to interpret. I hope you are starting to see that they are not that hard. It is readable. Yes, it's true. You need to get used to it, but once you are used to it, it is doable. Now, as an alternative, you can use SE alerts to make the interpretation a little bit easier. So SE alert is a command that interprets messages from the audit log, and it applies SE Linux AI. Yes, that's the SE Linux artificial intelligence. So it's going to interpret what is going on, and it will write meaningful messages to varlog messages. That's a little bit old. To the default system logger. It will still appear in varlog messages, but you will also find it in journal CTL. And next, you can run the SE alert command, including the UUID that you have just found, and you will get advice on how to troubleshoot specific issues. And sometimes this advice is pretty okay. In many times, this advice needs additional interpretation, and in some cases, it's just useless. let me check how useful it is. So journal CTL, pipe grep, SE alert. Has it been around? Oh, I may make a typo. It's journal CTL, pipe grep, SE alert. And there we go, lots of messages. First, I want to show you the SE Linux HTTPD related message. So you can see this message. In the message, it's printing SE alert with a -L followed by a UUID. This UUID can be looked up in the SE Linux event database. So I'm copying, I'm quitting, and I am running and piping through less. And there we can see that, oh, this is for web. Sorry, this is not the one I wanted to look at. I first wanted to show you that SE Alert sometimes is giving you pretty bad information. So let's have a look at the message that was logged a little bit earlier. And there we go, pipeless. And here we have SE Alert. So SE Alert is using plugins, and these plugins are giving you advice. And here we can see that the plugin catch-all labels with 83.8% confidence. So it is pretty sure about what you need to do, right? It's telling you that you need to change the label on web index HTML. And here is the part that I consider really lousy. SE manage f context minus a minus t file type on web index HTML. First thing I don't like, it's telling us to set the label on web index HTML. It's so much better to set it on the entire directory, but SE alert isn't getting there. It's only telling you about the web index HTML. So that's one thing to consider. Then the next thing to consider, and that is even worse, is where file type is one of the following. Well, one of the following, this is screen 1, here we have screen 2, here we have screen 3, screen 4, screen 5. Fortunately, it's telling us then you need to execute restore com. I hope you agree that this is pretty confusing information. And for most people, this will not be helpful at all. Fortunately, SE Alert is suggesting something else, and that's what we see right here. What is that? Well, it's telling you, hey, you can also do something else. Now, the reality is that most people won't even read what is here, and so allow this access for now by executing. And what is this doing? Well, it's doing an AU search. AU search is how you can search for SE Linux events. It's searching for SE Linux events that have HTTPD, and then it's doing something terrible. It's converting it to audit to allow. Audit to allow is a very powerful and also very dangerous utility that can convert deny messages into allow messages by generating a policy. So what we are doing here in this audit to allow, we are looking up everything that was denied by SE Linux related to HTTPD, and we are blindly going to allow it. The bad thing about it is that if SE Linux has been fighting off evil intruders all night long, after you have used these two lines, your HTTPD service, everything that has been blocked before is now allowed without you even thinking about it. And this is the part where I really hate SE Alert. But let's be realistic. Sometimes it can be a good help. And let's have a look at the SSHD one. Here we have the SSHD one. I am going to copy. I am going to paste. And I am going to pipe it through less. And there you can see plugin bind ports. And yeah, this time the advice is pretty useful. It's telling us to use SE managed port, and it's telling us that the port should be SSH port key or VNC port key or X server port key, and that is going to work. TL is asking, is that valid for the exam? I think you are asking about the terrible way. Let me put it this way. I have no insight in the Red Hat exam evaluation. That's the first statement. But if I would be responsible for writing the exam evaluation script, I would fail you for the exam if you would use this terrible solution, because really it's terrible. It's the worst thing that you can do. And I only have one thing to say about it. Don't. Why would you want to do it? Just don't do it. Don't take the risk, because it is really a terrible solution. Uh, I hope that's loud and clear, and I have nothing else to say about it. Right. I would like to tell you a bit about troubleshooting SE Linux. We have seen most things, but it might help to see it in the right context. So, what are you going to do if you are encountering an SE Linux situation? Well, first you need to verify that it's running on SE Linux. So you start using set enforce 0 and you check it again. Set enforce 0 is the same as set enforce permissive. You switch SE Linux to permissive mode, you try again, and if it next works, then you have confirmation that it was because of SE Linux. Then you are going to dive deeper. Next step shouldn't be a surprise. You are going to use grep avc on varlog audit log. You need to interpret the audit log. I want you to understand what is going on before doing anything else. And you will notice that you should do this often enough. You get familiar with it, and you know, oh, we have this situation. Hey, let me look up the appropriate context. You will find the appropriate context. You will set the appropriate context, and then it works. It really is easy like this if you do it a couple of times. For additional help, you can use SE Linux policy doc. I've warned you, be very careful with SE Linux policy doc on the exam, because it is very time consuming. But in real life, or in
Sopa.
situations where you do have time, it might be useful. What I would
Φρόνιμη
suggest,
κάτσε.
on the
Εκεί,
exam, if you
καλές.
don't find a solution
Μην
in
μιλάς
one
πολύ.
go, go do everything else before. Put the SE Linux problem to the last, and then you can also always do the SE Linux policy doc and try to look it up. But be prepared, SE Linux policy doc is going to cause you to lose serious time. And for additional help or confirmation of what you already thought, you can use journal CTL pipe grep SE alert. That will grep for SE alert. That will show you the SE alert. You run the message. You check the advice. You know, there
Μαλάκα,
is
τι είναι.
absolutely nothing wrong if you already have an idea of what to do to confirm that your idea is right using SE alert. But be very careful using SE Alert as the only solution. Oh, and by the way, SE Alert might not be working at all. Okay, everybody, I want 5 minutes. No, let me give you a little bit more. I give you 8 minutes for this lab. We are
Σώπα,
running
μωρέ,
quite
μωρέ.
smoothly, so I can allocate a little bit of time for this lab. I'm going to type history, and I know you
Τι
are
είναι,
also
είσαι
doing
έξω.
it at this moment,
Σε
because
χαμό,
this
στο
is the first
χαμό.
time you are working with SE Linux.
Κάτσε μέσα, κάτσε
I want
μέσα.
you to practice. I want you to
Καλά
have
είσαι.
the opportunity to try it for
Ναι,
yourself,
ναι.
to see how it behaves, and to investigate. Maybe you have additional questions that you do on here. I'm going to be silent for maybe 8 minutes now. But if you
Τι
have
σου
a
έγινε
question,
πάλι.
I will see and I will answer immediately.
Έστω. Έλα. Ναι. Φώτικα η τόσο.
I talked a lot, so I hope you don't mind me going silent a little bit.
bene.
Is what you use to make sure that hosts within your environment, computers within your network, can go out with one single public IP address and cannot be reached from the outside. It's a solution that you are using in your home network. One public IP address is on your router, and all your hosts set open. The Linux kernel provides an in RH remaining. So I am going to MD, you want coffee, you need to wait for 15 more minutes. Hey, consider break like a lab time like this, a micro break. I'm not following your link here, but it looks like coffee script. Probably something that will print that you want coffee, right? If you do coffee now, then the last hour is really very long. And I like every next slot in my courses to be a little bit shorter than the previous one to make it easier to survive the entire course. And with that, I'm going to shut down the break countdown timer. So what was the essence? Well, the essence was command 403. After moving etc hosts into your document root, you need a restore con to apply the appropriate context. The second part was something like se manage port -a -t. That is what you use to set the required port on your server. Okay, you have a randomly generated URL. Okay, that makes sense. Well, MD, I'm just guessing that it was about this exercise. I think we have talked enough about SE Linux. We are going to move forward. And yeah, we are doing quite all right. Normally, SE Linux is the last topic of day 3. Now we have time remaining, so I'm going to continue. And I am briefly going to tell you about firewalling. And can you imagine that we still have an hour left after this hour? That's only good. So how about firewalling? Well, firewalling is about filtering incoming traffic. Theoretically, you can also use a firewall to filter outgoing traffic, but that is not something you will have to do for RHCSA. On RHCSA, you need to be able, we'll get there, JS, no worries. On RHCSA, you need to be able to allow incoming traffic. Now, the thing is that in RHCSA, configuration of services is not a topic. So you should not expect an assignment where you first are going to install whatever service and then open the firewall. But still, you need some minimal knowledge about firewalling. This is really something minimal, so let's not make it too big, shall we? The Linux kernel provides a netfilter framework, and that's where firewalling is starting. And this netfilter framework takes care of firewall-related network operations. And that is packet filtering, network address translation, as well as port forwarding. Uh, Packet filtering is about limiting incoming traffic and make sure that only ports that you set open in the firewall are allowed. Excuse me. Network address translation is what you use to make sure that hosts within your environment, computers within your network, can go out with one single public IP address and cannot be reached from the outside. It's a solution that you are using in your home network. One public IP address is on your router, and all your hosts are using it to go out. Port forwarding, that is where you expose a port on a host or on a router that forwards to an internal port. The most important thing for RHCSA is packet filtering. Now, how does that work? Well, that works by using different stuff. In the background, we have NF tables. NF tables is new and it replaces good old IP tables. If you are used to IP tables from the past, then I have sad news for you, and that is that IP tables no longer plays a role. It has been replaced with NF tables, and NF tables really has a terrible command line syntax. I could dream firewalls in IP tables. I've tried it in NF tables, but really, it's not something that was designed to work with from the command line. So NF tables is the framework, and in order to make firewalling easy, we have Firewall D. And Firewall D is what is used as a front end. Excuse me. It's a service, and you are going to use Firewall CMD to configure your Firewall D service. And let me tell you about the components. So Firewall D has different components. First, there is the service, and the service is the main component. And that is a configuration that contains one or more ports. And if anything else is needed, like kernel modules, that can be included in the service as well. These services are pretty cool. They make firewalling easy. It's an XML file basically in which you put all of your configuration, and I will show you what it looks like in a little bit. Then we have the zone. The zone is a default configuration to which network cards can be applied. So if you have a so-called multi-homed server, excuse me, that's a server with multiple network cards, you assign one or more network cards to a zone, and you connect your configuration to a zone. And that allows you to configure a public zone and a private zone where you are doing something different for incoming traffic as what you do for outgoing traffic. That's what these zones are all about. Then we have ports. And ports are optional elements that allow you to access specific ports. So instead of defining a service and putting everything in the service, you can also directly use a port. I would say in real life, why would you want to do that? A service is a nice configuration that contains everything, whereas a port is an individual entry. For your own sanity, I would say manage everything through services and don't you think about managing individual ports, but it is something that can be done. Now, there are additional components. These additional components don't really matter for what we want to do here. If you want to know more in depth about Firewall D, I go a little bit deeper in my Linux security class next week. Hey, did I already make a shameless advertisement for my Linux security class? If at any point you think this class is not going deep enough, Come and join my Linux security class for more in-depth information. It will happen next week for the very first time. I'm all excited about it. It's a 5 hour class about Linux security. But we need to talk about firewall CMD because firewall CMD is the command that you are going to use to write firewall configuration. Now, firewall CMD is going to write the configuration to runtime. That means it will activate the configuration here and now, but it's not persistent. And that's annoying about firewall CMD. If you want your configuration to survive, and that's something that will be pretty important on the exam, you need to make it permanent. Using your rules in firewall CMD does not make it permanent unless you are using the minus minus permanent option. In practice, that means that you need to run your rules twice. Let me show you what it is about. And this little demo, really, believe it or not, is all you need to know about Firewall D for RHCSA. So first, systemctl status Firewall D is showing us the Firewall D status, and we can see that it's active and it seems to be all right. Next, firewall CMD minus minus list all, which is doing what? Nothing, because I made a typo, but that should be better now. List all is giving all configuration. On the exam, you are only going to work with a single homed server. That's a server with one network card. So that's what we see here. We have the public zone, and in this public zone, we have services cockpit DHCP6 and SSH that are open. Anything else can't be accessed from the outside. Now, if you want to make it accessible, you need to work with these services. Convenient command is firewall CMD minus minus get services. And there you can see all the services that are available in the current version of Red Hat. Now, if you want to work with HTTP to make Apache available, for instance, you can use firewall CMD minus minus add service HTTP. It's easy to make a mistake and to type HTTPD, but the firewall service is completely something else as the systemd service. So really, you need HTTP and not HTTPD. So now it is here and it is available. Can we verify? Yes, we can verify by using minus minus list all. There we go, HTTP. But if right now I'm using systemctl restart firewall D and I use my list all again, then you can see it's gone. And that's the part that you need to be aware of. So if you create a firewall configuration, make it persistent. Because without, it doesn't survive a reboot. And the first thing they will do on your exam with your virtual machines, they will reboot your working environment. Everything you do on the exam must be persistent. So repeat the command using minus minus permanent. And then you can see list all is still not showing it. But now if I'm using a restart, then list all is picking it up. And yes, I know you can do this in many different ways. This is the way that I'm showing you here. If you have used Firewall D before and you are doing it a different way, feel free to continue using the method that you are most familiar with. But if you're not familiar with anything yet, then this is what you might want to do. A little bit, a little bonus thing, and that is user lib firewall D services. Here are my services, and these services are XML files. So let's do a cat on userlib firewall D services http.xml, and here you can see what the service really is all about. As you can see, it's pretty simple. It's really not very sophisticated. Now, the same story applies once again in user lib, we find the system defaults. What are you going to do if you want some custom configuration? Well, your custom configuration, you are going to put it in the etc directory. So what does that mean? Well, that means that we need CP. I'm going to show you how it works. CP on user lib uh, firewall d services http.xml. I'm copying it to etc, not system d, sorry, firewall d services, and I'm calling it sender.xml. And next, what is this get all thing doing? Where is it? Oh, it's so far back. Yeah, get services. What is get services doing? Do we have the sender service right here? No, we don't. And that's because we need to restart something in Linux in many cases if you change the configuration. Systemctl restart firewall D. Let me do the get services grep sender, and there we can see that the sender service is available. I know the sender service doesn't have any different configuration. I'm too lazy to give it a different configuration, but I wanted to give you the insight of what is really happening when you are working with these services. And that is what you need to know about Firewall D. What are we going to do after the break? We are going to talk about time, and maybe we can even do scheduling tasks. And for sure, I want to talk about changing the lost root user password. The good news is that as it looks like at the moment, tomorrow will be completely dedicated to containers and the sample exam. But first, uh, let's do a break. If you feel like doing a lab, here is the lab. It's pretty easy, but yeah, feel free to do it if you want to be busy during the break. If you don't want to be busy during the break, that's okay as well. And JS, I'm still not forgetting about NFS. I didn't mention it here, but definitely NFS is on the list, and we'll talk about that as well. You know how it works? I give you a bonus minute in the break because, yeah, this was a lot of information, isn't it? So, bonus minute, see you in 13 minutes. Enjoy your break. Is there anything that we can do about it? Yes, you can use the topics should. Hello, everybody. I hope you're back. I'm here, and I know MB, you are here. About the firewall zones, you're asking, do we have to wait for securing SE Linux courses? I can't promise for the simple reason that there are many things that I want to do in my SE Linux, in my security course. And I am going to ask the audience in the beginning, which topics do you want to have much time and which topics should we do more quickly. So potentially yes, but I can't make it any more specific than potentially yes. I hope you understand. Right. So what is going to be next? Well, next, I feel like doing something fun to start with, and something fun is reset the root user password. Uh, That's a topic that sometimes raises additional questions, and I'm so happy that today I will have time for the additional questions. Now, the thing is that on Red Hat Enterprise Linux, the group boot prompt is not protected in any way. And that means that even if you don't have the root user password, if you know what to do, you can use the grub boot prompt to reset your root user password. And that means that you have access to all systems where you have physical access to. Is there anything that we can do about it? Yes, you can use a grub password. It's pretty easy. You use the grub2 set password command. That is generating a file that sets a password for the root user. And if you do that, then nobody has access unless they know the group password. Then you make things a little bit more complex. And you would only get access to a system if you can boot it from external media. So using a group password still is not completely secure, but it's more secure. But on the exam, it is not something that you are going to do. So on the exam, you need to know how to reset the root password. And this is rumored to be a pretty important topic. So let me show you how it works. I am going to launch a reboot, and I need access to the grub boot prompt. So 5 seconds to press escape. I was in time, so here we go. Grub boot prompt. Pressing E for edit, and to the end of the line that reads Linux, I'm going to add my stuff. And what is my stuff? My stuff is init is slash bin slash bash. Now, you are probably wondering, does the rd.break, the rd.break option still works? In my REL 8 courses, I was telling people about rd.break. And I have sad news for you. rd.break no longer is working in all situations. You should not use rd.break anymore. This is the only solution that still works. For those of you who are going to tell me that you found on Red Hat, on access.redhat.com, a document still telling you about rd.break, I can tell you in specific situations, rd.break is failing and leaves you nowhere. So if you are going to rely on rd.break anyway, you should accept the risk that you are going to fail your exam and pay the exam fee again because of this procedure. Well, then I hope for you that you have one of these constructions where you have a free exam retake. Red Hat, in some cases, is offering free exam retakes. But still, I wouldn't take my chances and you go for init is bin bash. Please remind the drawing that I made earlier today, the drawing of the root procedure, of the boot procedure. What is this init is bin bash? Well, init is bin bash is going to start your kernel and your init ramfs, and immediately after that, it is going to start a bash shell. And that is what I'm doing right now. Here we go. As you can see, I'm in a bash shell, and I was not prompted for the root password. In case you are old school and you are wondering, does systemd dot unit is emergency target not work? No, because that is prompting for a root password. So that's a useless option. Init is bin bash. That is what you need to do. Now, if we try to write something, then you can see that we are on a read-only file system. So that's the first thing that needs to be changed. How are we going to do that? By using this magical mount minus o remount comma rw slash. So the root file system in init is bin bash comes up read only by default. You want to change that. Well, mount minus o remount comma rw slash is going to make it read writable. So here we go. We have a read writable root file system. Probably you want to verify. Let me verify. I just did. I can write. Next, I can use pass wd root. Well, just pass WD, that would do as well because I am root already, isn't it? So I'm entering the new password and I'm entering the new password again. And then we need to check ls minus lz on etc shadow. And what do we see? We see etc shadow has crashed today. Do you remember what I told you before about setting SC Linux to disabled mode? Well, I can tell you, if you are in init is bin bash, you are at the earliest boot prompt possible, and in this earliest boot prompt possible, you don't have SC Linux. And that means that at this stage, SC Linux context labels cannot be managed the appropriate way. And as a result, we don't have SE Linux. I can't even check for context labels because in this environment, well, SE Linux is not loaded, so I can't check context labels. What I can tell you is that the context label on etc shadow is messed up. And what are we going to do about it? Well, there is one and one solution only: touch slash dot auto relabel. Touch slash dot auto relabel is going to trigger a relabel action when you are going to restart. But, small challenge, we can't reboot at this moment. Why can't we reboot? Well, if you want to reboot, you need to have systemd up and running. There's no systemd up and running. So a reboot is not going to work. We should probably see that. There you go. Reboot command not found. If you use exit, your system is going to crash. Because if you use exit, what is exit doing? Exit is exiting the current shell to go back to the parent shell. Now, the little challenge here is that my current shell, which is bin bash, is PID1. So there is no parent shell. So if I'm going to exit, the kernel is going to panic because the kernel needs a PID1. Feel free to try it for yourself. I'm not going to try it. I'm going to do the only thing that is right. I am going to use exec. Exec user lib systemd system. And in case you are wondering what is going on with this exec, well, a little bit of background information about how processes are started in a Linux environment. Normally, processes are forked. Come back on Monday if you want more details about that, because on Monday we are really going to go deep in process creation in Linux under the hood. But a fork of a process, that means that the new process is created as a child of the current process. So if I would type user lib systemd system, that would run systemd, but as a child as of the current process. And systemd must be PID1. The problem is I already have a PID1. So how can I replace my current PID1 with systemd? Well, that is what we are doing with this exec. Exec is making a copy of the current process code and replaces it with, in this case, user lib systemd system, and then removes the current process. So this is going to replace the current bin bash with systemd. And this is how you can boot the right way. And that is what we are going to do now. And if I don't make typos, it might even work. Sorry for that. And thank you, GC. That was just to make sure if anybody is still listening. I'm so happy, GC, that you are still listening and you even saw my typo, which course was fully intentional. Haha, you believe that, don't you? Well, that's up to you. Hey, folks, let's look at what is happening right now. The last 8 lines that you see on the screen, that is the SE Linux relabel. So this is good. SE Linux is picking it up. SE Linux relabel normally invokes a reboot as well. So we will see a relabel part 1, then it restarts, then it will pick up with relabel part 2. We need to give it a little bit of time. Hey, on the exam, this is unavoidable. You need to wait for this procedure to complete. What are you going to do while this procedure completes? I would say go for the obvious option and start reading other exam assignments. In the unlikely case that this procedure is getting stuck, that means 5 minutes later you are still waiting. I would say just reset your virtual machine to manually force restart it. Normally, the first relabel will do all right, but typically you might see a second relabel occurring. If I'm looking at it, I don't see a second relabel this time, and everything is good. And I see a login prompt. Now, I'm going to log in, and I'm going to enter my password. And while entering the password, I get access. If you enter the password, you try again, and you know for sure that you entered the right password, and it keeps on refusing, then you didn't fix the problem, and you need to start all over again, particularly on the relabel action. You could ask a smart question, by the way, about this touch slash dot auto relabel. The smart question would be, hey, what if I use restore con on etc shadow? Is that only also going to work? Well, the answer is if you are completely sure that only etc shadow was changed, it should work as well. It should work. That doesn't sound very sure, and that is why I would say go for the auto relabel option, because the auto relabel option does work. And there we go. It's done. Here's my history. What do we see in the history? Well, unfortunately, in history we don't see too many things, and that is because we were in troubleshooting mode. And in troubleshooting mode, well, we don't update the history. But this procedure is completely on the slide, so please read the slide. I've changed my mind about the next topic. I want to do NFS and AutoFS. So in the slides, that means that I'm going to get back a little bit. I skipped NFS and AutoFS earlier. Auto mount, aka AutoFS. So what are we going to do? Well, there is two things that I need to talk about. First thing is about NFS. Now, the funny thing is that for RHCSA, you need to know how to configure an NFS client. But if you want to configure an NFS client, it really makes sense if you also have an NFS server. And JJ, wow, really? REL 9 RHCSA is teaching you rd.break. Well, we can talk about it for a long time. I've been in occasions where rd.break really didn't work, and I got stuck. And in it is bin bash is the better way. And yeah, it's sad that you can't believe Red Hat anymore. I do have an opinion about that, but that's out of scope here. So let me not waste our time with opinions about stuff that doesn't matter. Let me bring up another CentOS machine. I need less than a minute. I need to find the IP address of the other CentOS machine, 142. Okay. I'm going to open a second tab and let me say loud and clear what I'm going to show you here is not a part of the exam. But you want to set it up completely, you better know how this works. So I'm going to use SSH student at 192.168.29.142. For your information, in rel 9, the root user is not allowed to SSH directly. So that's why I'm SSHing as user student. And once I'm in my user student shell, I am going to use sudo -i to open a root shell. Let me do a history -c so that we aren't bothered with any history remaining from previous classes. And let me set up an NFS server. What is NFS? NFS is about file sharing. So you are going to use the network file system to provide access to files that are on a server. First step is DNF install NFS utils. Now, why is everybody in Linux so excited about NFS? Well, there's a good reason for it, and the reason is that NFS is part of the Linux kernel. Yes, there is also Samba, CIFS, and stuff like that, but that's not a part of the Linux kernel. Because it's a part of the Linux kernel, it's very efficient. And if you use it wisely, it can even be secure. I'm not going to talk one single bit about security here. That's not a part of NFS. We don't even need to know how to set up an NFS server for the exam. So I'm keeping it really basic. But in case you are thinking, wow, Sander, what you are doing is really insecure and not good, then the only thing I want to say is, yes, I know, and you can make it so much more secure, but that would be a topic of a different course. You might want to check out my RHEL 7 RHCE. Before RHCE became Ansible, RHCE was about advanced Linux, and there you would set up a secure NFS server. Now I'm going to use mkdir-p slash NFS data slash home slash LDAP slash LDAP user 1.9. I'll tell you what we are doing with the LDAP user later, but for now I just want to have some stuff to share. Let me also use touch slash NFS data uh, file 1.11, and that is basically all that I want. I want some files to be present so that the demo is going to be a little bit more fun. Next, I am going to write etc exports. What is etc exports? etc exports is the configuration file in NFS where you are telling your NFS server which folders it should expose externally. So in order to do so, I'm putting in NFS data followed by star and between parentheses rw no root squash. And I'm also putting in slash home slash LDAP followed by star rw no root squash. What I'm using here, the star rw no root squash, is like the equivalent for Windows everyone full control. It's really not secure, but again, I don't care about security here. For your information, NFS is providing host-based access, and by specifying a star, I'm providing access to all hosts. Then RW means that users are getting read-write access, and user root, if user root comes in on a client, user root is welcome to maintain the user root privileges. And that is not secure at all, but uh, that is not important here. Wow, I saw a question in the Q&A. I'm confused about it. Hey, WM, I'll have a look at your question later before this class is over today. But I want to stay on the topic here. So next we are going to do what? Well, we are going to use the NFS server. AS, the operating system of my NFS server, is CentOS 9, fully equivalent to RHEL 9. I should say CentOS Stream 9 because there's no real CentOS 9 anymore. Good, etc export is showing these exports, and I'm going to do what? I'm going to use systemctl enable minus minus now NFS dash server to start it. And there we go. It's going to enable the NFS server. Let me also show you how you can find out which operating system you are using once the NFS server is up and running. If you use cat /etc/os release, you can see what you are currently using. So I'm using CentOS Stream version 9 right here. Functionality-wise, no difference with Red Hat Enterprise Linux. So what are we going to do next? Well, next I need to open my firewall. JS is asking if I need to run export fs minus AR. No, JS, because I just enabled and started my NFS server. Export fs minus AR is going to export directories you just added to etc export without restarting the NFS server. I want to keep it simple, and I am just going to restart the NFS server. As simple as possible is good for me. Next, I need for in NFS bind b RPC bind do firewall cmd minus minus add service $I minus minus permanent semicolon done. That should be a semicolon. What is that doing? That's opening a bunch of firewall ports if I would be smart enough to type it without echoes. Now it's better. So I have my firewall ports open right now. No, I don't have them open. I've added them to the permanent configuration. I need to use firewall cmd minus minus reload to reload the firewall. And now the firewall is reloading, and now it should be accessible. All right. Now I'm going back to the client. Let me type history, by the way, on the NFS server. So here is the NFS server history, and make a screenshot of it if you want to keep it. Then I can move to the client and continue the client part, because it's a client part that is really important. Everything we have done so far is pretty cool, but not really our HCSA exam material. What comes now is our HCSA exam material. We need to know how to mount NFS status. First thing, we need to ensure that NFS utils is installed, and then show mount minus E on command. Let's do it. ENF minus Y, NFS utils. NFS utils is the package that contains all the stuff that is required. Now I'm using show mount minus E on 192.168.29.142 because I don't have any name resolution. And this command is a very important command. This verifies the accessibility of the NFS server. So yes, the NFS server is accessible, and my shares are accessible as well. And that is what we need to verify here. So this is doing all right, and that means that we can continue. Show mount minus E is really important. JS short answer no. We'll get to AutoFS in just a little bit. So what can I do now that I verified that the mounts are available? Well, now that I verified that the mounts are available, I can start using them. Let's do that. And how do we do that? Well, manually you can use mount of the NFS server. I really need to create an entry in etc host, node to self. Let me try to not forget it this time. NFS data and I'm mounting it on MNT. Slash MNT is good enough for a temporary mount, and it's not complaining. And if it's not complaining, then normally it is happy. Yeah, that's the correct conclusion, SJ. So here I'm typing mount, and we can see that the NFS mount is here, and we don't need anything else. Of course you can, but you don't. And you also don't have to know about them, so let's not do this and let's just continue with the procedure. Because on the exam, I don't think you are going to put an NFS mount in etc FS step. In the exam, I think you are going to use auto FS. Quick entry in etc hosts, because really I am going to like putting this 142 as nfs server.example.com nfs server. I want to be able to use the name. So ping nfs server, and that would be working. Yay, there we go. I can continue and I can use AutoFS. What is AutoFS, also known as auto mount? These are the same. Auto mount is a service that you are going to use that is automatically going to mount your shares when you access them. So the thing is, I don't want my mounts to be mounted all the time. I want my mounts to be mounted only at the moment that somebody is accessing them. That's what AutoFS is all about. And no AS, I'm going to use the LDAP stuff later. I don't care about the LDAP stuff. We'll get there. Now, if you want to use AutoFS, you need to install it. It's not installed by default. So DNF install -y AutoFS. And then after installing AutoFS, you get a couple of files. And the most important file is etc.auto.master. Let's have a look at etc.auto.master, because etc.auto.master has some awesome examples. What do we see? Well, this is the line I want to talk about. In this line, we define the directory /misc. And this directory /misc is an AutoFS managed directory. That means that if you are going to access this misc directory, AutoFS is going to do something. What is it going to do? That is what you will find in etc.auto.misc. Now, it's kind of a funny structure. We have the master file, the auto.master, and the further specification is in auto.misc. Let's check out auto.misc. I'm using cat on etc.auto.misc, and there we can see a couple of items. The items in the first column, and the highlighted item is the one that I like most, are subdirectories. So here the highlighted line, just ignore the hash, which is a command sign, which makes it not effective. Just pretend it's not there. Let's just imagine that this is just Linux. What is this doing? This is specifying a subdirectory. What subdirectory? /misc/Linux. So if in this /misc directory I'm going to access the subdirectory Linux, what would it do? It's going to make a mount to ftp.example.org:/pub/linux. And it seems very confusing that they are using FTP in the name, but given the syntax of the mount, you can be ensured this is an NFS mount. Why do I think this is so important? Well, if you know how to find this etc auto.master and misc example, you probably know it, already most of what you need to know for the exam. And you can rebuild it. So what am I going to do? Well, I am going to, and this is on the slide, I am going to add a directory /data to etc auto.master, and I'm configuring that the further specification is in etc auto.nfs data. And then I'm creating my etc auto nfs data, in which I'm putting files, which is a subdirectory, -rw nfs server, :/nfs data. So let's do that. I'm adding etc auto dot master, and in etc auto dot master straight under the slash misc I'm putting slash data is already used. It is not a smart move. Let's make it NFS files, and the further specification is in etc auto dot nfs data. And next, I'm editing etc auto dot nfs data. The name nfs data, by the way, doesn't really matter. The only requirement is that it needs to be consistent. So I'm using etc auto nfs data, and in there I'm putting files dash rw nfs server colon slash nfs data. Next, I need to restart AutoFS, so systemctl restart AutoFS. While restarting, I need to start it, and probably I need to enable it as well. I'm skipping the part about enabling it, and I am using ls-l in slash. And what do we see? We see that the directory NFS files has just been created. So AutoFS manages the mount point, and by starting AutoFS, it has created the mount point. And if we use mount, we can see AutoFS right here. So it has etc auto.nfs data on nfs files type AutoFS. So it's an AutoFS mount. There is no real mount at this moment. It's only telling us that NFS data is watched by AutoFS. Now I'm going to use cd slash nfs files using ls minus a, because I want you to be convinced that really there is nothing in there. And I'm using cd files to access the subdirectory files, and I'm in the subdirectory files, and you can see this really is the NFS mounted subdirectory. So I'm typing mount, and what do we see now? We see that as I am in the subdirectory, it has mounted it. And that is what AutoFS is doing. AutoFS is about on-demand mounting. That's the answer to your question, SJ. etc FS step is permanent mounting. It's always there. AutoFS mounts are only going to be mounted at the moment that you are really going to access the directory. So TL wants to know, is it mandatory that the file that you are calling starts with auto? Yes, it is. Good. Now there's one more thing that I need to tell you, and that is the wildcard mounts. And this is what you can find on the next slide. So briefly about the slides. So the wildcard mounts. Auto mount is common for home directory access. Now, what is the case? The case is that in many environments you have a central server. LDAP is a server that is used a lot for that. So you have an LDAP server, and the LDAP server defines your home directory centrally. And you have multiple Linux servers that are accessing the LDAP server to get the credentials. And setting up the LDAP server is no longer a part of RHCSA, and be happy about it. It was a part of RHCSA in RHEL 7, and it was not the easiest part. So what has remained is the home directory. Now, how should you see that? Well, you have these LDAP servers, these LDAP users, and when the LDAP users are logging in, the users need to get access to their home directories. And these home directories can be provided by an NFS server, and that's what I'm trying to show you with this with this slash home slash LDAP stuff. So how does that work? Well, we need one mount in etc AutoFS, and the one mount in etc AutoFS is allowing you to do a wildcard mount. And this wildcard mount, that really means that it's going to allow you to access multiple mounts, and that's what we need to check here. How would that work? Well, you use star dash rw nfs server home ldep ampersand in your auto.ldep file. I'm fully aware that this needs a little bit more explanation. Oh, I'm too fast skipping over it. This is what we need. So what am I going to do? I am going to get back to etc auto.master. In my etc auto.master, I am defining slash home slash ldep. This is very important. You cannot define slash home because the directory that you are putting in here is becoming an AutoFS managed directory. And if I would use slash home, it is going to mount it over the current slash home, and nobody would have access to their home directories anymore. So that's not working. So I'm mounting on slash home slash ldep to create a subdirectory. And I'm putting etc auto.ldep as a secondary file. Then I'm editing my etc auto.ldep, and in etc auto.ldep, I need to specify subdirectories. So the subdirectory this time is star any subdirectory. It's going to be mounted as a read-write mount from nfs server colon slash home slash ldep slash ampersand. So it's star and ampersand. You mount star and ampersand represents the matching directory from the NFS server. So how would that work? Well, first I need systemctl restart AutoFS. I just changed the configuration, and without a restart, it's really not going to pick it up. Next, I'm going to use slash home slash ldep, which exists because AutoFS just created it, and I'm using cd ldep user 1. And while I'm doing that, it is mounting the matching directory from the central NFS server. And why is this useful? Well, because this makes it any user who logs in and who has their home directory configured, in this case to slash home slash ldep slash username, any user would mount the matching home directory from the NFS server. And that is how it works. That also brings us to the end of the day. I'm first going to create the history. And you know how it works. If you have any questions, start asking your questions. I already have some questions that are waiting for an answer. I'm aware of that. I'll look at them shortly. But first, I want to generate the course history. If you have any other questions, start typing them now. I'm reading what WM is typing. Just took RHCSA, was already scheduled for today. Oh, you took it today. Main takeaway for me is do not assume that you are starting from a disk with nothing on it when practicing LVM labs. Can I repeat that, or is it violating the NDA? I'm not sure about it, but WM, oops, I think I just repeated it. Oh, A wants to see etc auto.master again. Of course, you can see that again. And everyone, if you still have questions, ask now, because I don't have any other questions in the buffer. Here is auto.master. It's about the top 3 lines, OA. And if you don't have questions now, well, you know that we are back here tomorrow. So it's okay to ask the questions tomorrow. I will answer questions about today's topics tomorrow as well. So no problem at all. Everybody, I don't see any more questions. I'm going to call it today. Folks, I hope it has been useful today. I hope you learned a lot. And guess what? We are going to continue tomorrow. DM is mentioning you have seen net auto mounts. Net auto mounts are cool, but I'm going to say something that I really don't like saying. You don't need them for the exam, and as you don't need them for the exam, I really don't think we should be talking about them. Tomorrow, too little capacity maybe, and containers too big of tomorrow. With that, SJ, you are asking, are we going to correct the exam tomorrow? What do you mean when you say the exam? What I can tell you is tomorrow I have a mini sample exam, and you'll get solutions for the mini sample exam. That is correct, and that is what we are going to do uh, tomorrow. But for today, we're done. I'm going to have dinner. Thank you very much, everybody. Thank you for hosting the chat. And everybody, I will see you tomorrow. Take care. Bye.
All right, thanks a bunch, Sander. Everyone, I just want to just mention, see you back for day tomorrow. Have a great rest of your day. Take care, Sander. Sander. See you tomorrow.